Hi, I'm Rudy Garza, the President and CEO of the International Association of Electrical Inspectors. I wanted to personally welcome you to our electrical safety training session today. The training you are about to receive will be presented by the leading experts in electrical safety, not only in the United States, but in the entire world. It's obvious that whatever your profession, you've signed up for our training because you have a shared interest in electrical safety. Well, you've come to the right place because, quite frankly, we are the world's electrical safety leader. If you don't believe me, listen to what your peers have to say. Then, get ready to meet today's instructors.
People always ask me why I do it. Why do I put my life on the wire? But for me, it's my identity. It's who I am. As an IAEI member, I've met a ton of new friends. And some of those friends have led to the best networking opportunities that I've ever had.
For the past 35 years, IAEI has been a pillar in my career. The association has been there for me every step of the way. IAEI has put me one step ahead of non-members that are out there. It's nice to know that I'm in demand.
I love meeting new people, especially when they're just as passionate about electricity as I am. There aren't a lot of women in the industry, so it's been especially great to network with other women in the industry through IAEI's membership meetings.
Being an IAEI member has been great for my professional development. The fact that I can jump on the discussion boards to get any electrical-related question answered is really a valuable resource. I just feel when I walk into this building, IAEI walks in here with me. I highly recommend IAEI to anyone who wants to become better at their job.
It's given me many resources and things to be able to shape my understanding about electrical safety that I think a lot of people are not aware of. IAEI is not just a training program. Besides the training, there's also tons of wonderful people you can connect with in the industry. Being a member has definitely helped elevate my career.
IAEI offers education, friendship, and fellowship. For anyone thinking about becoming a member or taking a course, I say do it.
For those who are thinking of IAEI for their training and continued education, I say get involved as soon as possible.
The presentation that we'll do today is based on the 2020 NEC. Whenever there's a change from the 17 to the 20 code, I'll point that out to you. I'll be your facilitator today. Again, my name is Keith Laughlin. I'm the Director of Education here at IAEI. I was the Chief Electrical Inspector for a city here in the Dallas-Fort Worth area for a long time before I came to work directly for IAEI. I've been a member of IAEI for over 40 years. I currently chair Code Making Panel 7 for the National Electrical Code. There's 18 code making panels, and I have the privilege of serving as the chair of one of those 18 code making panels. I write a lot of our publications, the analysis of changes for IAEI and IAEI's 1 and 2 family dwelling electrical systems, and have a big hand in on the SOARS grounding and bonding updates. So most of you probably know me, but that's a little bit about myself. If you're not familiar with IAEI, I hope you will become familiar with IAEI, and there's our website right there, iaei.org. You can find a lot of information about how to join IAEI right there. A lot of our publications, the presentation we're going to be using today is available for anybody to purchase and use in your personal training. And you can find information about that at our website. Again, the presentation today is going to be based on the 2020 edition of the National Electrical Code. We're talking pools. we're talking Article 680. And the starting point, I guess, in order to understand some of the rules in Article 680, you got to know the arrangement of the National Electrical Code. And if you look at 90.3, it tells you how the code is laid out. And it tells us that the first 4 chapters are our general requirements. And then chapters 5, 6, and 7 can supplement or modify some of those rules we might find back in chapters 1 through 4. And I point this out because we're going to be in chapter 6 of the National Electrical Code today, Article 680. And if you're not familiar with the layout of the NEC, this can be confusing to you because you might see a rule in 680 that is different than maybe some of the rules back in chapters 1 through 4. Burial depth requirements at 300.5, the Article 680 now tells us that we have to comply with 300.5, but there was a time when we had our own burial depth requirements in 680 that differed a little bit from the burial depth requirements that you would find at table 300.5, and people would look at that and say, well, wait a minute, there's a conflict in the code, and they didn't understand the layout of the National Electrical Code. That when we did have that table, burial depth table, those burial depths modified those main rules that we found back there in chapter 3. So you got to keep that in mind anytime you're dealing with a subject matter that is not located in those first 4 chapters of the NEC. If we were looking at photovoltaics today, we might see some rules in 690 that would supplement or modify some of those main rules that you would see in the first 4 chapters. And we are in Article 680 today. And Article 680 is one of the most unique articles in the entire National Electrical Code. There are currently 8 parts to Article 680. For a long time, we only had 7 parts. The 8th part, electrically powered pool lifts, was added a couple of code cycles ago. But we have 8 parts here, and the beginning of each of those parts basically tells us that you have to stay in that part. In other words, if you're dealing with a permanently installed pool in part 2, 680.20 will tell us that you have to comply for that permanently installed pool. You have to comply with parts 1 and part 2 of Article 680. You don't take a rule out of part 5 or out of part 6 there or something and try to apply it to a permanently installed pool. And vice versa, you don't take a requirement out of part 2 for a permanently installed pool and try to apply it to part 3 for a storable pool. Again, that makes Article 680 a unique article in that for lack of a better term, you basically have to have permission to go from one part to the next. You just can't take a rule out of part 2 and try to apply it to part 5 without something in Article 680 telling you to do so. So you got to keep that in mind when you're studying Article 680 as well. So part 1, let's take a look at part 1. The areas that are highlighted right there are some of the new requirements from the 2017 to the 20 code that we'll take a look at as we go along. In looking at the scope of Article 680 at 680.1, it tells us that this article is going to apply to electrical instructions or electrical installations and wiring methods for swimming pools, wading pools, therapeutic, decorative pools, fountains, hot tubs, and so on. Um, anytime when you see the term body of water, that's going to apply to all types of bodies of waters that we just saw up there. So uh, if you were dealing with a pond uh, at a golf course or something like that, you wouldn't apply Article 680. You would apply Article 682 for naturally, artificially made bodies of water. So again, make sure that you even need to be in Article 680. Before we had Article 682, anytime you would come across a body of water like a pond or something, people would just naturally migrate to Article 680, and Article 680 doesn't cover every type of body of water. It does cover pools and wading and therapeutic and decorative pools, fountains, and so on, but not all types of bodies of water. And so check your scope there when you're trying to apply Article 680. That is covered by Article 680. The hot tub there, the pool, all of that would be covered by Article 680. This is not covered by Article 680. This is where you would have to apply Article 682, which again covers naturally, artificially made bodies of water. The photograph on your left right there is a photograph of the world famous Riverwalk down in San Antonio, Texas. And you wouldn't apply Article 680 right there. You would apply Article 682 to something like that right there. And here's just some of the areas that Article 682 would cover, talking about the scope of Article 682. Another thing that makes Article 680 unique is the definitions at 680.2. I don't know of another article in the entire code book that has more specific definitions that apply to Article 680. Now, typically, if you find a definition in Article 100, we have several definitions at Article 100, and historically that means that definition can be applied all the way across the code to any part of the code. But when you find a definition at 6.2 of any particular article, and in this case 680.2, that means that definition can only be applied to that particular article. And like we say here, there's several definitions that would apply to Article 680 that you will find at 680.2. They just keep going on and on there. New definition that was added in the 20 code for splash pads that we'll take a look at here in just a second. So yes, that would be applied to Article 680. Here's a typical splash pad that we'll take a look at, that new definition of a splash pad. But a lot of these would be covered by these definitions. And like I say, we've got several definitions. We'll take a look at a couple of them individually here. Typical pool that you might see at a hotel complex that would be covered by Article 680. Storable swimming pool, wading pool, immersions pools, storable portable spas and hot tubs. This is a critical definition in trying to determine which part of Article 680 am I going to apply to this particular body of water that I'm inspecting or getting ready to install electrical equipment at. And if what the body of water that you're dealing with meets this definition right here, capable of holding water to a maximum level of 42 inches, intended to be stored, and when not in use, constructed on or above the ground, constructed on or above the ground with non-metallic molded polymeric walls, inflatable fabric walls, and so on. If you can meet this definition, then you need to stay out of Part 2. You need to apply Part 3 to the particular body of water that you're looking at. We've got a new definition for a corrosive environment in the 2020 code. Now, this verbiage was found in the 17 code, but it was at 680.14, I believe it was, in the 17 code, and it was basically a definition of a corrosive environment. And of course, that needed to be located at 680.2, not at its location in the 17 code. And we'll take a closer look at this as we go along, but that's a new definition at 680.12 for the 2020 code. We've still got provisions for a corrosive environment, and this was a necessary step by Code Making Panel 17, beginning in the 17 code, where they put language in the code and basically a definition for a corrosive environment at 680.14. But again, that definition is now located at 680.2 with provisions for a corrosive environment at 680.14. And prior to this, we had a lot of wiring methods that were described, wiring methods that you could use in certain locations, you couldn't use in other locations. And it described, your wiring methods in the building. You had a certain set of wiring methods, and then on the building, you had another set of wiring methods, and then going to the pool itself, you had another set of wiring methods, and to kind of get away from that, beginning in the 17 code, Code Making Panel 17 came up with these provisions for a corrosive environment, and now basically for your underwater luminaires and the wiring methods for your receptacles and the lighting directly into the pool and so on. It's now just it's going to describe what this corrosive environment is here at 680.14 and the definition at 680.12. And then as far as your wiring methods are concerned, when you get to those areas, like at 680.22 for your luminaires, and it'll talk about the wiring methods, it'll say, if you're in a corrosive environment, and then you have to apply this definition. It no longer says in the building or on the building or things like that. It just simply will now say, if you're in a corrosive environment, these are your 4 wiring methods that are allowed, rigid metal conduit, intermediate metal conduit, things like that. And then it'll say, if you're not in a corrosive environment, then any of the Chapter 3 wiring methods are acceptable. So it really cleared up your wiring methods for Article 680 with this needed definition and needed provisions for your corrosive environments. Boy, I mean, how many times have you gone to look at a pool, maybe new construction, new pool, and you look at the wiring methods and so on, and you can go back to that pool after 8 months, a year, and all that electrical equipment looks like it's 30 years old. It's because historically you're in a very corrosive environment when you're dealing with a pool location with the chlorinators and chemicals and things that are typically used with a pool. Here's that definition of a storable swimming pool, wading pool, storable portable spas and hot tubs. And again, if you were to fall under one of these definitions here, you wouldn't need to be in Part 2 of Article 680. We have 3 types of equipment that are defined in Article 680: fixed, portable, and stationary equipment. And, a permanently installed pool, that's probably going to fall under the definition of fixed equipment, wouldn't you say? And something like a a therapeutic tub, um, would fall under the definition of portable equipment. Stationary equipment, that might be uh, a storable pool, would fall under that type of definition. New for the 20 code here, we have a new definition. We had some language in the code dealing with an immersion pool prior to the 20 code, but we didn't have a definition. And we have a new definition at 680.2 for an immersion pool, which is, of course, a pool for ceremony or ritual immersion of users, which is designed and intended to have its contents drained or discharged. So a baptistry at a church would fall under this definition right here, wouldn't it? A typical immersion baptistry at a church would fall under that definition. That I took this picture at my local church, and easily meets that definition. A fountain, amazingly to me, it describes, this definition describes what a fountain is, and then about 4 code cycles ago, that last sentence there had to actually be added, that this doesn't cover a drinking fountain or water coolers. There were some pretty zealous AHJs out there at the time that were trying to apply Article 680 in a office building in the vicinity of a water fountain, drinking fountain. And so that last sentence there had to be added for those guys. I would suspect that would fall under the definition of a fountain, wouldn't you? And you can have fountains that are located outdoors, or indoors, either one. But they would still fall under and meet that definition of a fountain in Article 680 or at 680.2. Hydro massage bathtub, that's Part 7 of Article 680. I doubt we'll be able to get to that today. Permanently installed bathtub equipped with recirculating piping systems, pump, associated equipment. They are designed typically to accept, circulate, and discharge water upon each use. Typical hydro massage bathtub. You can see an access panel down here for the equipment located under this hydro massage bathtub here. This is a important key definition in Article 680 for low voltage contact limit. Again, the code used to try to describe at several locations what low voltage was and was not. And so finally, about 3-4 code cycles ago, a new definition was added at 680.2 for low voltage contact limit. And with these 4 items right here, any of these 4 classifications would fall under the definition of this low voltage contact limit, which would allow equipment to go in closer vicinity of a body of water, perhaps. And we'll see this term here used quite a bit throughout Article 680. So if you hear me use that term, low voltage contact limit, and you don't know what we're discussing here, then you can always fall back to that definition at 680.2. Several places that, with the emergence of LED type lighting, that kind of threw a big spotlight, if you will, on the low voltage requirements in Article 680, and kind of led to that at that time new definition for low voltage contact limit. Here's kind of an illustration of some of that, and of course some of your landscape type lighting would fall under that type of low voltage contact limit. Typical landscape type lighting that would be allowed to go closer than 5 feet from the pool there because of its voltage limitations. Here's the definition of a pool: manufactured or field constructed, designed to contain water on a permanent or semi-permanent basis, used for swimming, wading, immersion, other purposes. I would put that under the definition of a pool right there. Permanently installed pool, which if the body of water that you're dealing with meets this definition, then you're going to have to apply. You don't have a choice. You're going to have to apply parts 1 and part 2 of Article 680. Constructed in the ground or partially in the ground, and all others capable of holding water in a depth greater than 42 inches. I hail from the great state of Texas, and of course everything's bigger and better here in Texas, and some of the manufacturers of storable pools have kind of adopted that motto, and they've been trying to, for years, they've been making their equipment bigger and better, and they've even crossed this line right here in some cases to where that quote unquote storable pool of theirs is capable of holding water in a depth greater than 42 inches. Well, as soon as they crossed that threshold right there and made that storable pool to where it was capable of holding water greater than 42 inches, in some cases, they just took themselves right out of part 3 of Article 680 and put themselves in part 2 of Article 680, which was the last thing they want to have to happen to their equipment there. So, but that's kind of the dividing line between storable pools and permanently installed pools. How much water is it capable of holding? All pools installed inside of a building, regardless of its water depth, are going to be classified as a permanently installed pool. Now we have a naturally artificially made body of water right out here. This is the bay of the ocean right out here, but this would be a permanently installed pool. So would that right there. We would have to comply right there as well. We would have to comply with parts 1 and part 2 of Article 680 for those types of bodies of water. 680, that's going to fall under that definition of a permanently installed pool. A little bit later, we're going to look at, is there any provisions or is there anything we need to watch out for with that metal fence? If that metal fence is within 5 feet of the inside wall of that pool, then yes, it has to be bonded to the equal potential bonding grid. Here's a typical immersion pool, a baptistry. that is intended to be filled up and then discharged after each use and so on. Spas and hot tubs, which is part 4 of Article 680, which I doubt we'll be able to get that far. But if you meet this definition, then you would apply part 4 of Article 680. Now there's a unique section of 680. 680.42, I believe it is, where it basically tells you an outdoor spa or hot tub, you have to comply with parts 1 and part 2. So basically, you've got permission right there in part 4 to treat an outdoor spa or hot tub as a permanently installed pool, and you would apply, for the most part, you would apply all of the requirements of part 2 to an outdoor spa or hot tub. But then you have rules for an indoor spa or hot tub that are completely different than a permanently installed pool, and you would apply only those requirements out of part 4 to an indoor spa or hot tub. Typical spa or hot tub, and if that were installed outdoors, then you're going to basically treat that as a permanently installed pool and apply part 2. Splash pads is a new definition that was added to the 2020 code. A fountain with a pool depth of 1 inch or less, intended for recreational use, does not include showers for hygienic rinsing prior to the use of a pool, and so on. Probably the most popular aquatic environment over the last decade or so has been a splash pad. And these things, there's nothing new about these. These things have started popping up, like I say, about a decade or so ago. But we had no provisions in, which part of Article 680 did you apply to these things? And there's a new provision in, I believe it's at 680.58, somewhere in there, in the 20 code, that basically would tell you that you got to treat this, you have to apply part 2 to these things. The same hazards that would be present at a permanently installed pool, as far as voltage gradients and things like that, granulates, would need to be applied right here. I took my 2-year-old granddaughter to a splash pad the other day, and it had a metal railing all the way around this, and even coming up in the front here around the splash pad. And absolutely, don't you want to ensure that that metal railing is at the same voltage potential as the water or any of this equipment right here as that metal railing, and so you would need to establish an equal potential bonding grid at a splash pad, just like you would a permanently installed pool. 680.3 talks about approval of equipment, and any equipment associated with a body of water needs to comply with Article 680 if that body of water meets the scope of Article 680, which we looked at a while ago, and all equipment is required to be listed for the application. Here's a typical label that you would see on a pool pump motor, and our listing requirements right here, and that has not always been true in a lot of articles, but in 680, talking about equipment needing to be listed, and then of course 110.3b would come into play, and which would tell us that this equipment has to be installed per manufacturer's specifications. Another typical piece of equipment with the third-party testing agency label on it. A lot of times you'll see a piece of equipment or you'll see a rule in the code. Especially years ago, it would say, this piece of equipment needs to be listed. Well, gosh, there's lots of equipment listed for what? And so today you'll see provisions in 680 particularly that'll say like for a transformer that would supply uh, power to lighting that would go directly into the pool. It'll tell you that that transformer needs to be listed and identified for pool and spa use. Similar to that label right there. This is a new provision at 680.4 that was added to the 2020 NEC. And this is a provision that talks about inspections after installations. We don't have any rule like this that I can think of in the entire NEC. And this basically was put into the code to give the AHJ a tool, if you will, to allow the AHJ to come back and look at an installation after its initial installation. Typically, the NEC would apply to a new installation. There's rules in the code for existing equipment and in a couple of three places, but several places. But for the most part, the NEC applies to new construction. And this was added because of that corrosive environment that you will find around a pool environment that just deteriorates that equipment so fast. So Code Making Panel 17 kind of took the first steps. I suspect that you're going to see this same type of a requirement perhaps in future code cycles for who knows what. Might even see something similar to this in 430 for motors or 440 for HVAC equipment or something. But this, it doesn't require the AHJ to go back and make inspections on existing installations, but it gives the AHJ permission to do such a thing. When this was being proposed in the 2020 code, there were some AHJs, the inspection community that said, wait a minute, I got more inspections than I can do in a day right now. And now you're wanting to add more to me. And again, this doesn't require an inspection. It just permits an inspection. And some of the larger jurisdictions that I've talked to, once they adopt the 2020 code, perhaps they will use this to say, we're going to set up a inspection protocol to where we're going to make an inspection on existing pool equipment in commercial occupancies every 18 months. At least every 18 months, we're going to go to all the hotels as an example, or health clubs, and make a visual inspection on some of this existing equipment. I think it would be very difficult to try to apply this to residential settings because there's so many, particularly in a large jurisdiction. But I mean, I'm just giving an example here. Maybe that might be where a large jurisdiction would start in using this new requirement at 680.4 to institute a method of making an inspection on existing equipment. Again, maybe perhaps at commercial installations every 18 months or every year or every 2 years or something like that. Because, again, this equipment is so susceptible to deterioration after a very short period of time because of the corrosive environment that you typically find around a pool environment. GFCIs, wow. Do you think GFCIs is a player in Article 680? You got a unique environment with Article 680. The old fire triangle that people talk about, you have to have three components for a fire, a source, oxygen, and heat. Well, there's a unique triangle in Article 680 as well. And people don't really put these three together a lot, but it's a recipe for GFCI protection. You got, first of all, you got people, and then you got water, chemically treated water. In other words, if that water can be any more conductive than it already is, add some chemicals to it to make it even more conductive. So you got people, water, and then the third leg of the triangle there is electricity. And you typically don't associate those three together, people, water, and electricity. But yet in Article 680, that's what the whole article is about, mixing those three components. And you do it on purpose. Nobody holds a gun to your head and says, hey, jump in that body of water there. I mean, and so that recipe right there, those three components, people, water, and electricity, makes a natural cocktail for the use of GFCI devices. And there are several GFCI requirements in Article 680 throughout Article 680 for GFCI protection. And you'll see GFCI protection on equipment such as receptacles, luminaires, motors. The GFCI devices that we use can be self-contained units. They can be the circuit breaker type. They can be receptacle type. There's no distinction between one. There's no place in Article 680 per se that says thou shalt use a receptacle, GFCI receptacle, over a GFCI circuit breaker, but yet 9 times out of 10, when you see GFCI protection, 99 times out of 100, when you see GFCI protection, it's typically delivered in the form of a receptacle device. Well, the code isn't requiring that. That's typically by economics, cheapest, easiest way to get out of this requirement. Is to use a receptacle type, which is cheaper than the circuit breaker. But the code does not distinguish between any of those. It allows any three of those in most cases. Now, the GFCI protection that you are talking about, all throughout Article 680, is Class A GFCI protection. And of course, Class A GFCI protection provides protection between 4 to 6 milliamps of current. In other words, if you're losing more than 4 to 6 milliamps of current out in the field somewhere, you got a loss of current. You got circulating currents out onto the frame of a water heater or a pool pump or something, and you're losing current at greater than 4 to 6 milliamps, then a GFCI is going to, that's what it's designed for, is to trip and stop sending current out into the field when you're losing current like that. That's what a GFCI circuit breaker is, matter of fact. You got a load out here that, let's say that's a 120 volt pool pump motor, and it pulls 11 amps of current. And so you've got a hot conductor coming out here to that thing, and you've got a neutral coming back. And if you were to do a cutaway of a GFCI device, you would see a CT donut, a current transformer inside, whether this be a receptacle or an overcurrent device. And what it's doing is reading the current going out and reading the current coming back. And it's adding up the current. A GFCI is an adding machine. And so if this motor here pulls 11 amps of current, you got 11 amps flowing here, you better have 11 amps coming right here or close there too. Let's say you develop a short out here or something and you're starting to lose current out onto the frame of this motor here, and you got 11 amps of current flowing right here, but you only have 9.5 or something coming back. That CT donut right there would sense that and say, wait a minute, I'm losing current out in the field, and it would trip at that point and stop sending current out into the field. And of course, that's how GFCI functions. And notice here also, does a GFCI need an equipment grounding conductor to function properly? No, it's reading the current between the phase conductor, the ungrounded conductor, and the grounded conductor. And if you have a loss of current between those two of greater than 4 to 6 milliamps, that's when a GFCI will trip. An installed GFCI overcurrent device. Rare photo right there. I like to never found this photo to take this photo for some of our publications because, again, a lot of people don't use these that much. Nothing in the code says, use a receptacle over this, but it's a lot of times you'll see a receptacle because, again, it's just cheapest, easiest way to get out of this requirement in a lot of cases. Here's a photograph of a 2-pole GFCI 50 amp circuit breaker. And I put this in the presentation to show some of those contractors out there that this thing, yes, it does exist. A lot of times, a contractor, you try to enforce GFCI provisions on a 240 volt hot tub or something, and they don't make such a thing. Well, yeah, they do too. Here it is. GFCI receptacle, Class A GFCI receptacle here that's going to trip between 4 to 6 milliamps of current. And again, you see these probably more than you would other types of GFCI devices. But again, economics drives that. Here's a faceless GFCI. And you might see that from time to time. You see these a lot with hydro massage tubs because when you get back to part 7, it'll say you need GFCI protection on that hydro massage tub. But the GFCI device that you use has to be installed in a readily accessible location. In other words, you can't put it under the skirt of the jacuzzi motor, the GFCI device. Now, you can put a receptacle under there, but it can't be the GFCI receptacle that provides the GFCI protection because that device has to be installed in a readily accessible location. And it also tells us that has to be an individual branch circuit for that jacuzzi motor. So if I were to put a GFCI receptacle on the wall there in the bathroom or something, as soon as somebody plugged a hairdryer in or something, then it would no longer be a individual branch circuit. So a lot of times you'll see an installer employ a faceless GFCI type device like this for something like a jacuzzi motor so that, it can remain a individual branch circuit. Here's just some of the locations that GFCI protection is called for in Article 680. Now, this is going to take about 4 slides because there are so many requirements for GFCI protection in Article 680. Why? That unique triangle, people, water, and electricity that we're mixing, and we're doing it on purpose. I said for splash pads, I said a while ago 680-58, I believe, but it's 680-50. So it just, there's lots and lots and lots of GFCI requirements in Article 680. We'll look at some of these individually as we move along here. There is a unique requirement in 680 dealing with GFCI requirements, and it talks about that conductors that supply pool equipment, such as a pool heater or something, the lighting that goes directly into the pool has to be GFCI protected. Well, those conductors, those branch circuits that supply those types of equipment cannot be installed in the same conduits or boxes or other enclosures that contain conductors that do not have GFCI protection. So like the pool heater doesn't require GFCI protection per se. So we couldn't put those conductors in the same conduit as the conductors going directly out into the pool. And this requirement is in the code, I think, because trying to ensure that we don't ever accidentally send a circuit out into the directly into the pool, like for that underwater light, that is not GFCI protected. And by the way, that the GFCI requirements for an underwater pool light, that was the very first GFCI requirement in the entire National Electrical Code. 1968 NEC was the first time that those four words were strung together: ground fault circuit interrupter. And the first provisions for GFCI protection were housed in Article 680. So yes, Article 680 and GFCI protection have a long, long history with each other, and it's where GFCI protection was birthed in Article 680. Now, the main rule here says we can't mix these conductors, GFCI protected conductors, with non-GFCI protected conductors, but there are some it's not an exception, but conditions that will allow that to happen. In the panel board itself, yes, you can mix those conductors. The origin of all those branch circuits are right there in the panel board. So, those provisions are allowed. Supply conductors that feed through to a GFCI device. In other words, you've got some GFCI protected conductors in the same conduit with some non-GFCI protected conductors, but those non-GFCI protected conductors are actually going to a GFCI device somewhere, at the next box or something like that. Though that's permitted. Conductors on the load side of GFCIs are permitted to occupy the same raceways, and equipment granting conductors are permitted to occupy the same raceway. Equipment granting conductors are by definition are not quote unquote GFCI protected conductors, but there are provisions here that would allow a equipment granting conductor to occupy the same enclosure as your or your GFCI protected conductors here. So 680.23F3 is where you find that requirement, and it's a very unique requirement in the code. I don't know of another place in the code that has language like this right here, talking about non-GFCI protected conductors and GFCI protected conductors, and being able to occupy the same raceways or not, or raceways or enclosures. And so, but you do have these 4 conditions here that are permitted. Again, equipment grounding conductors, yes, can go in the same raceways or boxes with GFCI protected conductors. These feed through conductors that are going to a GFCI device can be installed in the same raceway as GFCI protected conductors and so on. .6. Now we're still in part 1 of Article 680, which is your general requirements. And there are some provisions, grounding and bonding of equipment in Article 680. And there are, I believe, 7 specific types of equipment or devices that are required to be specifically grounded here that 680.6 addresses here. And this would be a good place, I guess, for us to distinguish between grounding and bonding. We've talked about this a little before in some of our webinars, but there is a difference in grounding and bonding. And, you know, for the most part, when you're talking about grounding, you're talking about connecting to earth. And when you're talking about bonding, you're talking about connecting together. So especially when we get to part 2, and especially when we start talking about an equal potential bonding grid, which one of these do you think we're going to be discussing, or we're going to be talking about the most? Are we going to talk about connecting stuff to earth, or are we going to be talking about connecting stuff together, equipment together? We're going to be talking about bonding for the most part. You know, the whole reason we establish the equal potential bonding grid is to put everything at the same voltage potential. You don't want the ladder that you use to climb in and out of the pool, that metal ladder, to be at one voltage potential, and the diving board or something to be at a different, or a metal fence within 5 feet of the pool at a different voltage potentials. Because if they're at different voltage potentials, and I touch that metal ladder, and then I also, with my other hand, touch that metal fence, and they're at different voltage potentials, well, what's going to happen? The current is going to naturally try to equal itself out right there, and it's going to use me as the conductor to do so. And if I've got enough current there, then, you know, I'm in big trouble. You know, the typical quote unquote let go threshold of the average male is about 16 milliamps of current, 17 milliamps of current. Past that, I'm past my let go threshold, where I can't voluntarily let go of that if I felt current there. You know, if it's 2, 3, 4 milliamps of current, and I touch one and then touch the other, and that current equals itself out using my body, I'm going to go wow and let go of that and get away from that. But yet, if it's higher than that, past my let go threshold, and that's why GFCI is set to trip at 4 to 6 milliamps of current. The average let go threshold for a child is about 5 milliamps of current. And you know, if a GFCI device reacts after I get to my let go threshold, well, what good's that do? So that's why GFCI is set to trip. A Class A GFCI device is set to trip between 4 to 6 milliamps of current. We do use the earth. You know, that's why we connect stuff to it, is because the earth typically has a voltage potential of 0. You cannot say that, you know, 100%, you know, because the earth can vary, but because of the mass huge size of the earth, if we introduce current into the earth, it typically just dissipates out into the earth because of the mass huge size of the earth. Now, the earth is a conductor of electricity, but it's a poor conductor of electricity because of its mass size. That dissipation factor is our friend. That's why we connect equipment to it, is because of that dissipation factor, allowing over voltages and things like that to dissipate out into the earth. Um, but again, because of the mass huge size of the earth. So again, kind of comparing grounding and bonding. In a nutshell, we're going to establish our connection to earth at your service equipment. That's where we're going to establish our grounding electrode system, grounding electrode conductor connected to this equipment right here. And for the most part, you establish that connection to earth at your service, and then you bond everything back to it. If you try to establish that connection to earth out here past your first means of disconnect, then chances are you're probably doing something you shouldn't be doing. Establish that connection to earth back here at your service, and then bond everything back to it. Now, for you installers that are on the webcast today, I hope this illustration here illustrates how important your job is. Weakest link theory. The weakest link you leave out here is as strong as the fault return path is back to this connection to earth, which would get, in the event of a fault, would get back to its source and then back to the overcurrent device to clear a fault. So first time you decide not to tighten one of these lock nuts with a pair of channel locks and just tighten it with your fingers or something, then you're introducing what? Resistance into this system here. And our fault return path 250.4A5 tells us, right, that we have to have as the least amount of resistance possible. So in a nutshell, ground at your service and then bond everything back to it. Grounding, our definition of grounding: connected to earth, connected to ground, or to some conductive body that extends the ground connection. Years ago, several code cycles ago, this definition of grounding said we had to be directly connected to earth. And Code Making Panel 5 changed that definition 5 code cycles ago to say this right here: has to be connected directly to earth or to some conductive body that extends the ground connection. So this piece of equipment right here, in no shape, form, or fashion is it connected directly to earth, but it is connected to some conductive body that extends this ground connection back here. And then bonded, connected to establish electrical continuity and conductivity. Married, connected together right here. We're, definition of bonding, not connected to earth per se, but connected together. And then you put the two together. So this piece of equipment out here is bonded, but it's also grounded because of this conductive body that extends this ground connection back here. Back in Article 100, our definition of a equipment grounding conductor, which is a key factor in complying with 680.6, where it tells us that these specific pieces of equipment that we're getting ready to look at are required to be grounded. Well, how do you accomplish that? Well, for the most part, it's going to be accomplished by connection to an equipment grounding conductor, a conductive path that is part of an effective ground fault return path that connects non-current carrying metal parts together and so on. So for the most part, when we talk about quote unquote grounding something, for the most part, particularly here in Article 680 at 680.6, we're talking about connecting to an equipment grounding conductor. So at 680.6, where it does talk about bonding and equipment granting, we bond in accordance with Part 5 of Article 250. Meet the equipment granting requirements of Part 6 and Part 7 of Article 250. And typically, we're going to be using a Chapter 3 wiring method, which would require an equipment granting conductor to be part of that wiring method. So these 1, 2, 3, 4, 5, 6, 7 items right here are specifically spelled out at 680.8, or excuse me, 680.6, that talks about this equipment has to be grounded and bonded. And again, for the most part, we're going to accomplish that with um, um, an equipment granting conductor. So a through wall lighting assembly is specifically required to be grounded and bonded, connected with an equipment granting conductor. Electrical equipment located within 5 feet of the inside wall of the pool is specifically required to be connected to an equipment granting conductor. This, and again, a good correlation between code making panel 17 and code making panel 5, in that 3 or 4 code cycles ago, these requirements right here said that it had to be grounded. Well, how do you accomplish that? So rather than say this equipment needs to be grounded, it now says it has to be connected to an equipment grounding conductor. Recirculating equipment, regardless of its location, it could be 65 feet from the pool. It's still required to be specifically connected to an equipment grounding conductor. Any transformers or junction boxes required to be specifically connected to an equipment grounding conductor. GFCIs. Now again, a GFCI does not need a GFCI, a equipment grounding conductor to function properly, but any GFCIs associated with Article 680, 680.6 tells us that they specifically have to be the branch circuit has to include an equipment grounding conductor. And panel boards associated with pool equipment is required to be connected with an equipment grounding conductor as well. With that right there, let's go ahead and take us our first break. Let's take about a 10-minute break. Let me put a timer up on the board for us. Help us all get back in here. So let's take us a 10-minute break, and I'll see you guys back here in about 10 minutes. You got to go get tested for coronavirus, but then is that, are you going to go get looked at by
Stop share that. Yeah, share my webcam so your timer will.
Can they still see the time?
It stopped when I hit that. I think it's still running, but okay. Well, evidently they picked up about 20 seconds on the breaks. Well, that's interesting to know that if I do that, you have to be sitting here to do that.
Don't do that. I mean,
No, I'm not going to do it
I'm
anymore.
perfectly aware that it's on.
I'm not going to do it
I'm not gonna
anymore.
pick my nose or anything like that. I know it's on. If I need to do something, I walk over here while we're in that
I
break.
just was worried. I didn't know. So.
Okay. Okay, welcome back. Let's go ahead and get started back. Okay, we're still in part one of Article 680 for our general requirements. And at 680.7, it talks about grounding terminals, equipment grounding and bonding terminals. Those have to be identified for the use. They have to be identified for a wet location a corrosive environment. Um, and the manufacturer of the equipment that we use in Article 680, like the water heaters and things like that, the pool pump motors, um, the manufacturers do a good job right there in providing uh, terminations that do meet these requirements right here. They have to be um, uh, in order to stand up in a wet or a corrosive environment. They typically are going to be copper alloy or stainless steel. Um, if a terminal is required to be in contact with the soil or direct buried, of course, it's going to have to be listed for direct burial use. And again, the manufacturers do a great job in providing a termination for a bonding jumper like this from the equal potential bonding grid to terminate on that piece of equipment, and using a lug that would be identified for either a wet environment or a corrosive environment or whatever it might be. Some of these typical connections here. 680.8 talks about cord and plug connected type equipment, and fixed and stationary equipment. Now that excludes the underwater luminaire. Um, those are permitted to be connected by a flexible cord and plug to allow for removal or disconnection, maintenance and repair. Now, even that underwater luminaire is permitted to be connected with a flexible cord, but not a cord and plug connection. But some of your other equipment is permitted to be cord and plug connected. Has to meet these four conditions here, not exceeding 3 feet in length. Now, for something for a storable pool, that cord can be up to, I think, 15 feet um, that you'll see in part 3 if we get to there. But for the most part, you're limited to not exceeding 3 foot in length for your flexible cord for a cord and plug connection. Has to contain a copper equipment grounding conductor, size per 25122. Has to terminate in a grounding type attachment plug, and the equipment grounding conductor uh, has to be connected to a fixed metal part of the assembly. 680.9 talks about overhead conductor clearances. The clearances that we have to maintain above a body of water like a permanently installed pool are all taken from the maximum water level. Now, guys, where's the maximum water level going to be? There's places in 680 that talk about the normal water level, but this one talks about the maximum water level. And so when it talks about maximum water level, you're talking about that pool deck. And so if we need to have a 22.5 foot clearance above this pool, we're talking about, for the most part, we're talking about measuring from the deck itself, even though the water might be, you know, lower than that. We're talking about that deck because that deck is the maximum water level. And 680.9 talks about overhead power conductors. This used to talk about service conductors here, and a lot of people would apply this overhead clearance to, say, if we had a feeder going from the main dwelling unit right there to a garage or an outbuilding that contains all of our pool equipment. Um, uh, technically, that wasn't covered per se, but under the 20 code, uh, it was changed from service conductors to overhead power conductors. Um, and if you look at the table that accompanies 680.9A, you'll see that for any type of a power conductor, feeder, services, branch circuit, whatever it might be, if you have to go over that pool, then you're talking about a 22.5 foot clearance above that pool. That's a long ways up there, but the that metal pole attached to that skimmer net that I use to clean leaves off my out of my pool and things like that. That's a pretty long pole right there, and so I mean that's why we have to get up to those heights that you see right there. If you have to go across the pool, the best thing to do would be route it away from the pool if you have to go overhead. But if you do have to go over that pool or within a 5 foot distance of that pool, um, uh, um, 10 foot distance of that pool overhead, then you would have to maintain that 22.5 feet of clearance. And here's the figure that's even in Article 680 that accompanies the table and gives these directions. So for uh, power conductors, overhead conductors, uh, for the most part, now there's different categories right here. If you're talking about a residential pool or a pool at a hotel or something like that, chances are pretty great you're going to be in that category right there. Insulated supplies or service drops from 0 to 750 volts to ground. And that's where that 22.5 foot clearance comes from right there. It could be up to 25 or 27 feet with higher voltages, type voltage overhead conductors. So if it's a conductor from the power company, and of course that's not even covered by the National Electrical Code, that would be covered by the National Electrical Safety Code, and that NESC is also where these distances come from. All these distances here correspond to the overhead clearances that you would find in the NESC as well. From diving boards and platforms and things like that, you're still looking at, again, probably those voltages right there, and you'd be looking at least a 14.5 foot clearance from a diving board or observation deck or something like that. This can get a little confusing because it also talks about a horizontal clearance, and that's where I got that 10 foot, where I said, if you're going to go over a pool, then you actually have to come 10 foot out from the pool and then up 22.5 feet. And it's because of this C here talking about this horizontal measurement from the inside wall of the pool. So, well, I've got a slide coming up that we'll look at that'll talk about that a little bit more. And so the overhead power conductors, you're looking at a 22.5 foot clearance for overhead power conductors. And the best way I can describe this, it's kind of a hard concept to picture in your mind, but you can think of it like this. If you had a heart-shaped pool, you would have a heart-shaped 10-foot circumference around that heart-shaped pool that you would need to bring into play here, 22.5 feet tall. If you had a rectangle pool right here, you've got this 22.5 foot, 10 foot out from the water's edge rectangle that any overhead conductors could not penetrate into that yellow area there. Now, if you stay outside of this, now again, this is a triangle because the pool's a triangle. If this were a kidney-shaped pool, this would be a kidney-shaped area here, 10 foot out from that kidney-shaped pool. But as long as you stay outside of this yellow shaded area right here, you're not in Article 680. You're in what? Article 230 for overhead service conductors, or something like that. 225 for branch circuits. Now, our communication conductors, telephone lines, things like that, those only have to clear the pool by 10 feet. Those have a signal running across it, but not voltage. And so you have a lesser overhead clearance for something like a communication conductor than you would a power conductor. Now, don't get that confused with a network power band broadband cable, because those do have not only a signal running across them, but they have current as well. And so you would treat a overhead network power band broadband communication conductor just as you would a power conductor, and would have to comply with the 22.5 feet of clearance if, again, if you needed to go over that pool. Again, best thing to do is avoid the pool, in my opinion. Part 1 at 680.10 talks about pool heaters, electrically pool heaters. And if you have an electrically pool heater, a lot of them are gas fired. But if it is an electrically powered pool heater, it has to be subdivided so that you don't have loads exceeding 48 amperes, and has to be protected at not more than 60 amperes. Ampacity there cannot be less than 125% of the total load of the nameplate for either your branch circuit conductors or your overcurrent protection devices as well. So if you did have an electric pool heater, then you're going to have to comply with those provisions there at 680.10. Here we get into our underwater or underground wiring methods around the pool. And this has gone through some pretty extensive changes over the last 3 code cycles right here. Again, we used to have a table right here that gave us some burial depth requirements when we were within 5 feet of the pool or under the pool that we had to comply with. And for the 17 code, and I submitted the public input. I was trying to get an answer. I had a code question. I was sitting on a code panel at a IAEI section meeting, I believe it was. And one of my questions had to do with, if I'm within 5 feet of the pool, I know I have to comply. At that time, it was 680.10 for our underground burial depths. But what if I get outside of that 5 feet with the same branch circuit? Do I still have to comply with 680.10? And my answer was no. Once you got outside of that 5 feet, then you were no longer in Article 680. You were in 300.5 at that point. And not everybody agreed with that answer. So I submitted a public input to code making panel 17 for the 17 code to say, what I was basically looking for was, for seven. I didn't want Keith to tell those people that you didn't comply with 680 once you got outside that 5 feet. I wanted code making panel 17 to tell them that. And 17 they were trying to come up with some burial depth dimensions, and they finally, I think, just got kind of tired of arguing the point, and they finally just kicked that table that had been in part of the code since about the 1968 code. They just kicked it right out of the code book and just said, hey, even within 5 feet of the pool, comply with your burial depth requirements of 300.5. So that's what we have even today under the 20 code. But in that 17 code revision, there was a long-standing 5-foot circumference. We have a 10-foot circumference around the pool when we're overhead, but underground you have a 5-foot circumference where you have some wiring restrictions, and that 5 feet or circumference around the pool underground inadvertently got left out of the 17 code. Well, it's back for the 20 code. Um, um, Underground wiring still talks about underground wiring not permitted under the pool unless it is necessary to supply pool equipment. So, in other words, the branch circuit going to the underwater pool light, yes, can be under the pool, but a branch circuit going out from the house to um, a yard light or a feeder going out to a woodworking shop detached can't go under that pool. And again, the minimum burial depth requirements are now governed by table 300.5, whereas we used to have a table back here in 680. Again, at that time, it was located at 680.10, but that's no longer in the code. So your burial depth requirements, even within 5 feet of the pool, now have to comply with table 300.5. So you do still, once again, we have the underground wiring, 5-foot horizontal from the inside of the pool. And those are, uh, uh, those, that 5-foot distance there is that's where you would get into some of your corrosive environments and those type of things as well. So your underground wiring within 5 feet horizontally of the pool, there you see a list of your acceptable wiring methods within that 5 feet of the pool. If you get outside of that 5 feet, then a chapter 3 wiring method that is acceptable for underground would be permitted. But within 5 feet of the pool, you would be limited to these 1, 2, 3, 7, I guess, wiring methods that you see on the screen there. In the in this area where I live in the Dallas-Fort Worth area, particularly for that underground, um, the light going directly into the pool, we see a lot of red brass conduit. Now, what that actually falls under, it falls under the category of rigid metal conduit. Um, and there's even language that talks about red brass being a suitable wiring method at 680.11 right here. So these burial depths right here for these branch circuits here associated with this pool, we used to have to comply with table 680.10. We now have to comply with 300.5. And there was a little bit of a difference between old 680.10 table burial depths and the burial depths that you would see at 300.5, but that's no longer the case. Again, that table is not part of the code anymore. And for these, even within 5 feet of the pool here, you would, as far as burial depth requirements, how deep do these need to be buried and so on, you would have to comply with table 300.5 in chapter 3. if you have to come within 5 feet of the pool, like you see here, you've got uh, another man's property over here. The property line is right there. There's going to be a fence right there, but yet right down here somewhere is this is probably a dwelling unit, and the electrical easement comes right here. The electrical underground service has to come right there. Um, and you don't have your 5 feet. You have to come within 5 feet of the pool with that underground uh, service lateral or something. Um, there is provisions in the code now that would allow this to happen, but you would have to install that uh, in one of those wiring methods that we talked about: rigid metal conduit, intermediate metal conduit, or so on. And a lot of people will look at that rule, and if you look at that language, it all actually talks about a complete wiring system. So if you had 100 feet of service lateral here from the transformer to the meter base, but only 15 feet of it actually comes within 5 feet of that pool, it would not be code compliant to just sleeve that 15 feet that comes within 5 feet of the pool. You would have to use one of those wiring methods that we saw back there for that entire length there, that entire 100 feet right there. Would have to be installed in one of those wiring methods that was uh, an acceptable wiring method right here. Uh, rigid metal conduit, rigid polyvinyl, PVC, something like that. .680.12 talks about equipment rooms or pits, and you'll see these a lot of times at like your hotels and things where you have a pool, and sometimes you'll see an equipment room at a large dwelling unit, but 680.12 talks about the electrical equipment installed in these rooms or pits. Um, uh, if they do not have drainage, then they have to be installed to prevent water accumulation during normal operation. Takes into consideration, a flood or something like that. But under normal operations, um, you have to put that equipment in a equipment room to where it's not going to get flooded. Um, Equipment is required to be suitable for the environment, and guess what? Guess what that environment's going to be in a pool equipment room? It's going to be a corrosive environment. So the equipment needs to be suitable for that type of an environment. Here you see some typical pool equipment in a pit or equipment room at again, maybe this is a large hotel or something right here. Your maintenance disconnecting means. You got to have a maintenance disconnecting means. It can be one or more. It doesn't have to be just one. It has to simultaneously disconnect all of the ungrounded conductors. Has to be installed in a readily accessible location. Where are we going to find that definition? In Article 100. Need to be able to walk up to that piece of equipment without having to climb over another piece of equipment or something like that. Has to be within sight of the pool, fountain, or whatever we're dealing with there. It has to be located at least 5 feet horizontally from the inside wall of the pool, unless it is separated from the pool by some type of a permanently installed barrier, like a wooden fence or something. But for the most part, it has to be this, your maintenance disconnect means has to be at least 5 feet from the water's edge, and you take that measurement from the water's edge, shortest path that a cord could take, and so on. The language that we have at 210.8 right now for GFCIs, where it talks about how do you take a measurement for a GFCI device, shortest path the cord could take without piercing a floor, wall, ceiling, so on. That all that language in 210 was fashioned after this language right here at 680.13. So that disconnecting means right there needs to be at least, unless you got some type of permanent fence or something right here, separating the pool from the disconnecting means you'd have to have at least 5 foot of clearance from the inside wall of the pool to the edge of that service disconnect or maintenance disconnect. I'm sorry. Here you see a typical maintenance disconnect for pool equipment. I took this photo several years ago, or 5 or 6 years ago, and the pool was, gosh, 25 feet from here. But you see it's installed in a readily accessible location. Sometimes you'll see this disconnect installed right here, or maybe right here or something, and that'd be a code violation because that's a accessible location, but not a readily accessible location. Here's a typical maintenance disconnect, and look where it's located. Is that installed in a readily accessible location? I don't think so. I think you got a working space violation right here. Working space, and that's not a readily accessible location. It's an accessible location, but not readily accessible. 680.14 is where it talks about our corrosive environments. And this is the section of the code that the authority having jurisdiction would use to determine if a part of the code or a equipment located in a certain location, whether it's a corrosive environment or not, using that definition that we saw at 680.2. And some of the language right here would allow the AHJ to make that determination as to whether or not it was a corrosive environment or whether it was not. And just quite frankly, that would be a broad interpretation for an AHJ to say that your pool equipment is not located in a corrosive environment based on this code language right here and our definition that we see at 680.2. If you are in a corrosive environment, then there's your 4 wiring methods right there that are permitted. Once you get outside of that corrosive environment, well, here's a typical corrosive environment, an equipment room for pool equipment. If I'm the authority having jurisdiction, that's a corrosive environment, and all that equipment needs to be listed and identified. The electrical equipment here needs to be listed and identified for that location. This was a photograph taken by Dave Williams up in Michigan, and this pool equipment right here was about, if I recall, Dave said that was about 16 months old, 18 months old. And, looks like it's been there for 35 years. That all those chemicals in that room right there, chlorine and bromine and stuff like that, really has a deteriorating effect on our electrical equipment in those areas. Very corrosive environment. All right, let's move over into part 2 for permanently installed pools. And if we look at our definition again of a permanently installed pool, those that are constructed in the ground, if it's constructed in the ground, it is a permanently installed pool, regardless of the depth of water that it can hold. Partially in the ground, all others capable of holding water in depths greater than 42 inches is considered a permanently installed pool. And 680.20 tells us when it comes to a permanently installed pool that we have to comply with part one that we just got through looking at, all those provisions that we just got through looking at, and part two, the provisions we're getting ready to look at. Now, does 680.20 say comply with part one, part two, and part four? No. So for a permanently installed pool, we're going to apply two parts of Article 680, part one and part two. If we're in a corrosive environment, the wiring methods for motors to a permanently installed pool are intermediate, rigid PVC, rigid thermal resin setting conduit is permitted in those corrosive environments. MC cable that is listed for the location. Not all MC cable is listed for a corrosive environment. But there is certain types of MC cable that has the um, polymeric sheath on the outside of it. That is listed for a corrosive environment. And all those wiring methods have to contain a copper equipment grounding conductor. Size, again, for table 25122, and in no case can that equipment grounding conductor be smaller than number 12 or 12 American wire gauge. If it's installed in a non-corrosive environment, once you get outside of the pool equipment room or the vicinity of where the pool equipment is located outdoors or something, and you're headed down the wall to a junction box or something, and you're outside of that corrosive environment. And again, who's going to determine what the location is? Whether it's a corrosive environment or non-corrosive environment, that's going to be the authority having jurisdiction that makes that determination. But once you get outside of that corrosive environment, then any Chapter 3 wiring method is an acceptable wiring method. The interior of a dwelling unit, for instance, is more than likely the ASJ is going to consider that a non-corrosive environment. So non-metallic sheath cable would be a permitted wiring method here. Outside of that corrosive environment. Now that would not hold true for, in the corrosive environment itself. Here's some typical photographs showing some typical wiring methods going to motors associated with a pool. If you need some flexible connection, and you probably would need a flexible connection at a motor because of the vibration and so on, then liquid type flexible metal conduit or liquid type flexible non-metallic conduit is an acceptable wiring method. Of course, you're going to have to use listed fittings listed for whatever environment you're in. So again, there's a photograph showing some liquid type flexible metal conduit as an acceptable wiring method for flexibility to get around the cable installations there. Who showed up on the job site first? The electrician or the cable guy? Looks like the cable guy got there first. Liquid type flexible non-metallic conduit or flexible metal conduit, an acceptable wiring method for flexibility at a motor. a motor, pool associated motor is permitted to employ a cord and plug connection. Again, we're limited to, for a permanently installed pool, remember where we're at right here. We're in part 2 for a permanently installed pool. 3 foot in length, has to have a copper equipment grounding conductor, and the not smaller than number 12, terminating in a grounding type attachment plug. So a cord and plug connection is permitted for something like this right here. And you see this is a common installation at a, particularly at a dwelling unit. If we have a double insulated pool pump motor, a listed cord and plug connection has to be incorporated into the motor itself. Again, provide grounding means for the internal non-accessible, non-current carrying metal parts of that motor is what that equipment grounding conductor would achieve there. Where the equal potential bonding grid is connected to the equipment grounding conductor of the motor, which is a provision that we'll look at here in just a second. Then the bonding conductor to a replacement motor is an example of that. Again, we'll look at that here in just a second. The branch circuit wiring method has to comply with 68021A, which calls for an insulated copper equipment grounding conductor. So that provision right there might eliminate what? Non-metallic sheath cable, unless it had an insulated equipment grounding conductor. Here's a typical double insulated pool pump motor. For the most part, not all of them now, but for the most part, I see the pool pump motors that I see today are typically double insulated pool pump motors. There's some pool pump motors, and all of those are double insulated pool pump motors. GFCI protection for a permanently installed motor, for a permanently installed pool. GFCI protection is required. There is an exception for if you have a listed low voltage motor, and that would have to meet that provision of not exceeding the low voltage contact limits of those voltages that we saw at that definition back there at 680.2. The outlet that supplies all pool motors, if you do have whether it's a cord and plug connected or a junction box hardwired, it still requires GFCI protection. On a branch circuit rated 150 volts to ground or less, and if it's 60 amps or less, whether it be single phase or 3 phase, it calls for Class A GFCI protection. We had some provisions that used to talk about you only had to have GFCI protection for 120 volt or 240 volt, and so you'd have people installing a 208 volt motor rated 208 volt and say, well, I don't need GFCI protection. So the code language was changed right there to say 120 volt through 240 volt to clearly indicate that even a 208 volt motor does call for GFCI protection. All outlets, again, regardless of whether it's cord and plug connected or directly wired, direct wired, does call for GFCI protection if it meets these provisions right here. 60 amps or less, so on. So all of these would call for GFCI protection, with the one exception for if you had a listed low voltage motor that did not exceed those current ratings in that definition for low voltage contact. There is a provision that talks about, this is new for the 2020 code right here. And a provision was added here for replacement motors. If you had a older installation, you went to replace that motor and it was not GFCI protected, the new motor going in for that replacement motor would call for GFCI protection if it were, 150 volts to ground or less, 60 amps or less, and so on. You would have to go back with GFCI protection even on a replacement motor. So even on an existing installation where you went to replace this motor right here, if it were not already GFCI protected, it would call for GFCI protection in that situation. And again, that's a new requirement that was added to the 2020 NEC at 68021D. Let's talk about receptacles in and around pools or close to pools and all. And this is a unique requirement for 680 that we don't see in other places in the code. And we do have a requirement here that calls for at least one 125 volt, 1520 ampere general purpose receptacle to be located. It cannot be located any closer than 6 feet from the water's edge, but it can't be located any further than 20 feet from the water's edge. That used to apply 2 code cycles ago. That rule right there only applied to residential pools. And 17 code, I believe it was, that was the residential part was removed to where it applies to all pools now. So even at a hotel pool, a commercial pool, a new construction would call for a receptacle located at least no closer than 6 feet, no further than 20 feet from the inside wall of the pool. In order for that to comply with this requirement, it can't be located any higher than 6'6" above the platform or deck or whatever it might be. Receptacles for pool pump motors, those have to be located also with at least 6 feet from the inside wall of the pool. And of course, they have to be GFCI protected and be of the grounding type, those receptacles for a pool pump motor. Any type of other receptacles have to be located at least 6 feet from the inside wall of the pool as well. So if you had more than one, you're only required to have one out there. But if you had more than one, then they have to be at least 6 feet from the inside wall of the pool as well. 125 or 1520 ampere, 125 volt receptacles located within 20 feet of the pool would have to be GFCI protected. Now, if it's an outdoor pool, chances are pretty great that it's going to have to be GFCI protected because of its location, located outdoors. But if it is within 20 feet of the pool, all bets are off. It does have to be GFCI protected. And again, these measurements are taken shortest path that a supply cord could take without piercing a floor, wall, ceiling, doorway, and so on. And again, that's that language that you see today at 210.8. That's where that language was crafted from, was this language right here at 680.22. So I have to have at least one receptacle located no closer than 6 feet, but no further than 20 feet from the pool. I have a pool at my house, and my children are grown now, but when they were teenagers and all, um, I can recall one time my son had some buddies over and they were swimming one day, and they had gotten all the floats and all out, and I have a receptacle that's located about 12 feet from the water's edge, and rather than put the floats up uh, where they should have gone, my son left one of the floats just um, leaning up against the wall, and it actually covered up that receptacle that was out there, that convenience receptacle. Well, the very next day, my daughter came home from college, and she went out to sunbathe and all, and she headed out the door, and she had her radio, and this was years ago when we didn't have, uh, iPads and stuff like that, or get your music off your phone and all. And she had a radio, a portable radio that you plug in, that she wanted to take out there and listen to music with. And I saw her going out there, and then I looked over there and I saw that float that was covering up that receptacle. And I started to run out there and, you know, whoa, there's a receptacle right over here. But I wanted to see what she would do, and she did. She looked around looking for a receptacle, and she didn't see one because it was covered up with that float. So she put her radio down and she went to Dad's garage and she got an extension cord. And she went into the living room and plugged in the extension cord, run the extension cord through the door, which was a violation. Uh, my daughter doesn't know the code like her dad does, I guess. And she went out toward the pool, and when she got within 6 feet of the pool, she stopped, right? No, she took the end of that cord and was going to take it right to the edge of the pool and plug her radio in. And of course, that's when Dad ran out there and, whoa, wait a minute. And I showed her where that receptacle was over there, just covered up with the um, float. And had she seen that receptacle, she would have been perfectly content plugging her radio in right there and staying, keeping that radio, electric plugged in radio with out of that 6 foot zone around the pool there. But without that receptacle there, then she had to resort to an extension cord. And that's the reason that convenience receptacle is required to be there, at least one, no closer than 6 feet from the pool, no further than 20 feet from the pool, for just a scenario that I just described right there. What if you had an existing building, dwelling unit, whatever it might be, and you added a new pool, and you've got a existing outdoor receptacle that is now going to be within 6 feet of the pool? Can you leave that thing? Well, not really. You know, you'd have to get rid of that existing receptacle that's too close to the pool and relocate it somewhere outside. And even the receptacle for the pool pump itself has to be located at least 6 feet from the inside wall of that pool. Um, um, Now, these receptacles on the inside here, separated with a permanent barrier like a wall and things like that, could actually go within 6 feet. But the ones that are there to serve that area there would have to be located at least 6 feet from the inside wall of that pool. This was new for the 2020 code. If you had a pool equipment room, you're now required to have at least one 125 volt, 15 or 20 ampere rated general purpose receptacle in that pool equipment room. There was no provision for a receptacle to be in that room um, uh, prior to the 2020 code. You probably had them in there, but um, there wasn't a requirement to have one there, and it does have to be GFCI protected. Again, When it comes to those receptacles, how do you take those measurements? Shortest path a supply cord could take without piercing a floor, wall, ceiling, doorways, things like that, window openings, um, or other effective permanent barriers like a wooden fence or something. Let's talk about lighting in these areas. Let's say we have a new outdoor installation. In other words, we got a new pool that we're installing outdoors. We're generally required to keep luminaires at least 5 feet horizontally from the inside wall of that pool, unless we can maintain at least a 12-foot distance above the pool with that new luminaire, and then it can go within 5 feet of the water's edge. But for the most part, you got to stay at least 5 feet from the inside wall of the pool. Luminaires and lighting outlets that are installed within 5 to 10 feet. Let me see what I've got here. Yeah, let's look at this right here rather than read all that language right there. So for the most part, for an outdoor pool, if I cannot maintain 12 feet, let's say I put a new pool in, existing structure, and I've got a floodlight out here, and that par floodlight is 10 feet above the maximum water level here. That can't stay there. I have to go at least 12 feet in order for that to stay there above that water's edge. Now, I have to stay at least 5 feet horizontally in this box right here. You basically have 4 boxes back here. Here's the water's edge right here, and in this lower box right here, I can have no luminaires whatsoever. Now, in this box right here, which is 5 feet from the water's edge, there's the water's edge right there. If I have an existing luminaire that is rigidly attached to the building, if I GFCI protect that existing luminaire, it could stay right there. It's more than likely not GFCI protected. There's nothing in the code that would call for it to be GFCI protected, without that pool being right there. So it's an existing luminaire. It's within that 5x5 zone right there. I can keep it there. If it's rigidly attached, that's kind of subject to interpretation right there. Rigidly attached, and if I GFCI protect it, I can leave it there. Now, let's go 5 foot away from the water's edge into this 5x5 zone back here. I'm permitted to put even a new luminaire back here, but it has to be GFCI protected. Now, in this zone right back here, and I hope you keep in mind, guys, that it's hard to draw something like this on a one dimension illustration like this. These these 3 5x5 boxes right here would actually encircle the whole pool. So if that's a kidney shaped pool, you would have this kidney shaped 5x5 zone all the way around the pool there. But this zone right back here, we're 5 feet away from the pool, 5 feet above the deck. We can have a luminaire there. It has to be rigidly attached again, but it does not have to be GFCI protected. This one back here, it doesn't say a thing about this one having to be rigidly attached. So I guess it could be loosely attached if you wanted to here. But those are your provisions right here for your luminaire locations around an outdoor permanently installed pool. Indoor installations, a little bit different here. you still have to maintain that 12-foot distance above the pool. But there are provisions where you could go as close as 7 foot 6 inches. If the ceiling fan, paddle fan, or luminaire was identified for such an application. In other words, identified for a wet location for the most part. Damp or wet location, the ASJ would have to determine whether or not that's that area right above the pool there is a damp or wet location. And of course has to be GFCI protected to get within that 12-foot clearance. And again, we're talking indoors. We're not talking outdoors right now. We're talking indoors. If we had an indoor pool, totally enclosed pipe, so on. So main rule still says indoors, get at least 12 feet from the maximum water level. But if you have a ceiling fan or a luminaire that is identified for such a location, then you can actually come up to or as close as 7 foot 6 inches. You couldn't have anything on an indoor pool, spa, or hot tub within that 7 foot 6 inch zone there. And you have those same distances that we talked about, the outdoor requirements. Those same distances are there for indoor pools as well. The only difference in an indoor and outdoor pool is this 7 foot 6 inch allowance. If these are identified for such an application. So that ceiling fan right there, that is actually, it's hard to tell with this one dimension photo there, but that ceiling fan there was actually about 3.5 feet out over that pool right there. And that would have to be identified for this installation, identified for a damp or wet location, which it doesn't look like it is, but maybe it is. I'd have to be at least 7 foot 6 inches from that deck right there to that fan to allow that fan to be above an indoor pool like that. We do have some low voltage luminaires that are permitted to go closer than the 5 foot distance that you typically have to stay away with luminaires. Has to be the type that doesn't require connection to an equipment grounding conductor and cannot exceed the low voltage contact definitions of those voltage limitations that we saw back there at 680.2. They have to have a listed transformer or power supply that is listed and identified for swimming pool and spa use. And it will say right on those transformers or power supplies that it is listed and identified for swimming pool and spa use. It won't just say it's listed, it'll say listed for swimming pool and spa use. Article 411, which is our low voltage lighting, also allows low voltage lighting systems to be installed in close proximity, closer than that 5 foot distance that we saw a while ago, if it's permitted by Article 680. And this at 680 22B6 here is where you find that permission. So Article 411 and 680 are in harmony with each other right here on these low voltage lighting systems around the pool. Very common to find that type of lighting, especially with the LED type lighting these days, with lighting to be closer than the restricted 5 foot areas that we saw a while ago. as long as this type of lighting system does not exceed those low voltage contact limits. And there are several manufacturers that make such low voltage lighting equipment that is permitted in a installation like this right here. LED low voltage type lighting. The 17 code recognized listed low voltage gas fired units and igniters, low voltage igniters that can be located closer than 5 feet from the inside wall of the pool. Again, this type of an equipment, whether it be a fireplace, fire pit, gas fired luminaires, those are very popular these days. They have to fall into that low voltage contact limit definition, and they do not require grounding by connection to an equipment grounding conductor. Any type of metal equipment associated with these types of equipment would have to be bonded to the equal potential bonding grid because they're within 5 feet of the pool typically. A lot of this, some of this equipment would be all plastic type equipment anyway, but if it did have some metal components to it and it's within 5 feet of the pool, it would have to be connected to the equal potential bonding grid. Why wouldn't you want it connected to the equal potential bonding grid so that everything is at the same voltage potential? Any metallic gas piping for such a gas fired unit, if it had cast iron gas piping or something like that, would of course have to be bonded to the equal potential bonding grid. So the 17 code did recognize this type of equipment. Prior to the 17 code, we just had nothing in the code that covered this type of equipment right here, a fire pit, right there beside the pool and so on. But as long as this is all under that low voltage contact limit, the electrical power supply to this, then the code would allow that within 5 feet of the pool. Nice looking pool right there with those gas fired, I don't know what you'd call those, decorative units there. Again, you have that same provision here for your luminaires that we saw for receptacles. Shortest path a cord could take without piercing floors, walls, ceilings, and so on. Switches are required to be located at least 5 feet from the inside wall of the pool, again, unless they're separated by a permanent barrier like a fence or something. There are switches that are listed and identified to be used within 5 feet of a pool. Sometimes you'll see a air switch type thing. That's an example of a switch that is listed and identified to be used within 5 feet of the water's edge. But for the most part, a switching device is required to be at least 5 feet from the inside wall of the pool unless it is listed for closer distances. Other type of outlets. What would an other outlet be? We talked about receptacles. We talked about luminaires. We talked about switches and all. What about communication outlets? Outlets for a phone or something like that. Those have to be located at least 5 feet. At least 10 feet from the inside wall of the pool. And again, that shortest path measurement thing would be utilized here as well. Fire alarm outlets, things like that, would have to be located at least 10 feet from the inside wall of the pool. Any type of other equipment located in close proximity to the pool has to be located at least 5 feet horizontally from the inside wall of the pool. Now, this is new. This is a new requirement for the 2020 code cycle. And what would other type of equipment be? Well, we were starting to see pole-mounted PV arrays, things like that, that were located just right next to the pool. And, you know, so for the 2020 code, a limitation was put on such type of quote unquote other equipment, that equipment be located at least 5 feet from the inside wall of the pool unless it is separated by a permanent barrier such as a fence, wall, something like that. So something like a PV array right there would have to be located at least 5 feet from the inside wall of the pool. Prior to the 20 code, I think an ASJ would have had an issue with this, but there wasn't really a section of the code that helped him with this, him or her with this. And the new requirement at 68022 paren E would help in that situation now. Let's go ahead and take us our last break. Again, let's take a 10-minute break and we'll come back and finish up. Okay, let's start back up. Let's talk about the underwater luminaires, and then we'll get into uh, 68026 for equal potential bonding grids. 68023 covers our underwater luminaires, underwater lighting, and talks specifically about wet niche luminaires, dry niche, no niche, and so on. 90% of the time, 95% of the time, the underwater luminaires that you see with your typical, especially a residential pool, are going to be a wet niche luminaire, but there's rules for the other types of underwater luminaires as well. They're at 68023. The underwater luminaire lighting has to be supplied either directly by a branch circuit or through a suitable listed isolated type uh, isolated winding type transformer or power supply. And again, this is where I was talking about a while ago, where the transformer or power supply has to be listed, labeled, and identified for swimming pool and spa use. So isolated winding type, in other words, you would have a grounded metal barrier or double insulation system between your primary and secondary outputs. And you're going to be looking, if it does have a transformer power supply associated with a luminaire going directly into the pool, look for that label saying that it is identified as pool and spa. Let's see. I thought that said that directly on there somewhere. Low voltage landscape, swimming pool, spa, accessory transformer, rain tight enclosure, and so on. If it goes directly into the pool there, either has to be the low voltage contact limit or GFCI protection has to be installed in the branch circuit. There's locations in 680 where you can provide GFCI protection in the feeder to certain types of equipment, but that equipment or wiring method going directly into the pool, the GFCI protection is specifically required to be located at the branch circuit level right there. If no underwater luminaires are permitted to be installed where the supply circuits are over 150 volts between conductors, there are some provisions here. It's not an exception per se, but provisions for electric discharge lighting like fluorescent type lighting and so on that would exceed the 120 volts. But that would be only in that ballast type right there. But for the most part, you're limited to not over 150 volts between conductors for those that equipment going directly into the pool. 150 volts between conductors for the supply circuits has to have the GFCI protection directly in the branch circuit, unless it's the low voltage type contact limit. Has to be located. The luminaire itself has to be located at least 18 inches below the normal water level. Now, remember a while ago when we were talking about measuring those distances above for overhead clearances and things, we were talking about the maximum water level. This is a place where it talks about the normal water level, and that's going to, I know my pool fluctuates, that normal water level, but you got to be at least 18 inches below the normal water level. They do make underwater luminaires that are permitted to go in lesser depths than that 18 inches, but in no case any less than 4 inches below the normal water level. Think about it. If you were in a pool and you're hanging on to the side of the pool, though, if you put it at lesser depth than 18 inches, especially if you were hanging on to the pool right in front of that luminaire, you don't want that luminaire to where it's directly in front of your heart. You want it lower. I don't guess they're worried about other appendages, but there, that's why that rule's in the code to keep the luminaire from typically being at heart level when someone was hanging on to the side of a pool. Luminaires that are installed in the face up or upward position have to have a lens that adequately guards or prevents contact. Um, you've seen those before where they have a protective uh, grid type lens over them. Um, uh, if they don't have that guard on them, they have to be listed for that particular type of application with a very thick type of glass or plastic there. They're typically dependent on submerging. In other words, you don't need to put power to them until till they're surrounded with water. That keeps them from burning up, keeps them from overheating. Um, uh, so at least 18 inches as far as their location, at least 18 inches below the normal water level unless they're listed for lesser uh, depths, and in no case can they be uh, greater than 4 inches uh, above the or from the normal water level. At least 18 inches, so that again, if you were hanging on to the side of that pool right there, that luminaire right there wouldn't be directly in front of your heart. The different types, the dry niche, no niche, and wet niche, and again, the ones you've seen are more than likely again, especially associated with a residential pool, would be classified as a wet niche luminaire, which calls for their whole listing calls for them to be completely surrounded with water. Most common one, of course, is wet niche luminaire. Forming shells have to be equipped with provisions for conduit entries. Typically, they're brass or other approved corrosion resistant metal. Sometimes you'll even see a plastic non-metallic um, forming shell for a wet niche luminaire, but even with those, they'll have a a, um, a lug with a metal strip from that lug to the front of that forming shell that can bond the metal uh, luminaire itself, the ring that typically goes around the outside there once the luminaire is actually installed. Um, if you choose the wiring method as PVC, non-metallic conduit system, then it has to have a number 8 copper bonding jumper installed with that non-metallic conduit. If it was a metallic conduit, then the metallic conduit can serve as the bonding means between the junction box and the forming shell and so on. Typical wet niche luminaire. There you see a non-metallic forming shell, and it's got a brass connector for a bonding jumper from the equal potential bonding grid right there, and there's the front of it right there. They'll typically come with that metal strip right there that can serve as a bonding means for any metal components of the luminaire itself once that luminaire is actually installed. Listed potting compound is required around those fittings, and here's that number 8 coming to the forming shell, and a listed potting compound is required right there on those fittings as well. Your wiring methods for the wet niche luminaires, metal conduits listed and identified would either be uh, uh, rigid, uh, intermediate, that would either be red brass or stainless steel. If and non-metallic PVC is permitted, but if you do use PVC or liquid type flexible non-metallic conduit, that number 8 American wire gauge solid or stranded copper bonding jumper would be required from the junction box to the forming shell right there, from right there to right there, uh, to serve as the bonding means between the junction box and the forming shell right there. There's a typical um, forming shell for a underwater luminaire, wet niche type luminaire. A lot of them, most of them I've seen, are equipped with a flexible cord, because there are provisions in the code to where in order to change that light bulb, you have to be able to get that luminaire up to a dry surface, the deck or something, and not have to be in the water to change out that uh, light bulb right there if that bulb burns out, which they do quite often. And here's that provision there at 68023B6. And most of the time the installer will leave enough cord right there. It'll, just have it rolled up, around the forming shell or the luminaire right there to where you got enough to get it up onto a dry surface for maintenance or servicing of that. Now you're gonna have to get in the pool to take out a couple of screws right there that holds this thing in place in the forming shell right there. But typically it'll have enough flexible cord right there to get it up to the deck or a dry surface to service that thing without having to be in the pool as you service that thing. Something like that right there. There is a new provision in the 2020 code that talks about where you have a spa with a bench that you don't have to go all the way to the deck. If you have the ability to drain the spa, and if you can get it up to that bench, and that bench be a dry location with the water drained out of the spa, then that can satisfy this servicing requirement as well now. The conduits, there's your wiring methods that are acceptable in a corrosive environment. And again, the AHJ is going to have to determine if it's a corrosive environment or not. But, and I don't know how the AHJ would determine that it's not a corrosive environment. So that would be your wiring methods right here. In a corrosive environment, you got to have an insulated copper equipment grounding conductor, not smaller than number 12 as well, going to that underwater luminaire. On the supply side, in other words, over here, in a corrosive environment, you'd be limited to those wiring methods that we just looked at. If it's in a non-corrosive environment, then a Chapter 3 wiring method. And in a corrosive environment, you have that same provision for a copper insulated grounding electrode conductor. Excuse me, gosh, I'm sorry, equipment grounding conductor, not smaller than number 12. Non-corrosive environment, your Chapter 3 wiring methods are permitted. Typical Chapter 3 wiring methods. Liquid type flexible metal conduit or liquid type flexible non-metallic conduit are permitted for a connection to transformers or power supplies. The total length there, you're limited to 10 feet. in any one length, with any one length being limited to 6 feet, total length of 10 feet. In other words, you might have 4 feet to the transformer and another 6 feet going out to a junction box or something like that. So you'd be limited to 10 feet total length, but 6 feet in any one length. Now, there are provisions to where the type B liquid type flexible non-metallic conduit can be in lengths longer than 6 feet. Now that type B is where you order from the factory, liquid type flexible non-metallic conduit with the conductors already installed. And you would just tell them, what length you're needing. And this is just a illustration of that. Junction boxes have to be listed, labeled, and identified for use with swimming pool environments and so on. You can't just put a normal bell box out there. The junction boxes have to be listed, labeled, and identified for the application. Have to have threaded conduit entries or non-metallic hubs for PVC connection. The junction box itself is either going to be made up of copper, brass, some type of suitable plastic, or other approved corrosion resistant metal. That probably needs to say identified right there rather than approved. Who does approving? The authority having jurisdiction. If I were the ASJ, I would want to rely on a third-party testing agency for the corrosion-resistant material right there. But hey, that's what it says. The junction boxes have to have electrical continuity between every connection. In other words, if you were using a plastic junction box, the manufacturer of that plastic junction box will typically provide you with some type of a metal strip that would have the proper size holes for the entries there that would provide that electrical continuity between the metal conduits connected to something like a plastic junction box. You have to be careful about where you locate them on finished walkways and things like that, to where it's not a tripping hazard. And you have to have no fewer than one more grounding terminal than the number of conduit entries. And of course, that's a manufacturer's provision, but if that manufacturer provides 4 conduit entries into that listed swimming pool junction box, then they'd also have to provide at least 5 terminations for grounding terminations for bonding jumpers, equipment grounding conductors, and so on to be terminated within that listed junction box. The junction boxes themselves has to be located at least 4 inches above the deck or 8 inches above the maximum water level. So if you had just a single level pool, do I have to put that junction box as 4 inches or 8 inches above the deck? Well, the deck is typically going to be that maximum water level, isn't it? So I would have to go at least 8 inches with that junction box there above the deck there, and it has to be at least 4 feet from the inside wall of the pool as far as my location of the junction box itself. Now, if I had some type of split level pool, then yeah, now I only have to be 4 inches above this deck because that's not the maximum water level. That would be the maximum water level down here. Here's some photographs of some listed junction boxes for swimming pool and spa use. And this particular junction box, I believe, has 3 conduit entries. So the manufacturer would have to provide me at least 4 terminations or grounding terminations. I think there's another one right there. to comply with our requirements here. And of course, they do make plastic listed junction boxes for swimming pool and spa use. Looks like the birds have enjoyed these junction boxes as well as the swimmers. Listed junction boxes for swimming pool and spa applications. Again, can't just put a regular bell box out there. It has to be listed and identified for swimming pool and spa junction box applications. 68025 talks about feeders to pool related panel boards. And if they're installed in a corrosive environment, then again, there's your wiring methods right there. Rigid metal conduit, intermediate metal conduit, so on. In a corrosive environment, that feeder is going to have to include an insulated copper equipment grounding conductor, not smaller than number 12. Aluminum conduit is not permitted in a pool area where it is subject to corrosion. So in a corrosive environment, that feeder right there for this panel board associated with pool equipment would have to contain an insulated copper equipment grounding conductor. If I'm in a non-corrosive environment, then again, a Chapter 3 wiring method would be permitted. Any Chapter 3 wiring method that is identified for whatever application we're getting ready to put that feeder through. Chapter 3 wiring methods there for non-corrosive environments. All right, let's talk about our equipotential bonding grid. We did a whole webinar on this a month or so ago. And we'll probably spend the remainder of our time talking about our equipotential bonding grid here. This used to be called a common bonding grid. And I'm going to say 2008 code, somewhere in there, maybe 2005, I can't remember. The term here was changed from common bonding grid to equipotential bonding grid to help illustrate exactly what this is for. And it's for what? Equal voltage potential, to equal out the voltage, the potential for voltage on any type of metal equipment associated with this pool, any fixed metal parts within 5 feet of the pool, and so on, required to be connected to this equipotential bonding grid. Now, guys, again, what are we trying to achieve here? Are we trying to achieve grounding connected to earth or bonding connected together? We're trying to achieve bonding here. You know, look at that pool right there in this photograph. You dig a hole in the ground, probably, you know, on one end there, you're probably 10, 12 foot deep. And then you line that hole with steel rebar, concrete. How much more in contact with the earth can you get than that? And if you're not in contact with the earth enough, let's pour about 40,000 gallons of water on top of it and press it into the earth even more. It's not a question here, guys, of being grounded. That component right there is grounded, believe me. What we're trying to achieve is bonding right here. We're trying to ensure that all metal parts, that ladder right there, this pull lift, that railing right there, the structural metal components of this deck, like this right over here, are all bonded together, mechanically, electrically bonded together, so that my body, my granddaughter's body, your body won't serve as the conducting element, between two conductive parts that are at different voltage potentials. You want them at the same voltage potential to where your body doesn't have to act as that conducting body between two conductive parts that are at different voltage potentials. That's what we're trying to achieve here with our equal potential bonding grid. Same voltage potential. That's what we're trying to get at right here. We're not talking about a fault return path necessarily here. We're talking about a bonding path to bond components together. I've been out to job sites before around the pool, and we'll talk about this a little more, but the electrician, the installer would take one continuous length of number 8 copper, and there's nowhere in Article 680 that calls for that to be in one continuous length. But they'll take one continuous length and run it all the way around the pool and, hit the deck steel and the diving board and the pool ladder and run 50, 60 feet over to the circulating pump and so on. And he'll use about 200 feet of that number copper, and he's bonded everything, and then he's standing there with this number 6 copper, the end of that number 6 copper in his hand, and he doesn't know what to do with it. And what he should do with it is just drop it and get away from it. But yet, I've seen installers drive a ground rod right there and connect it to a ground rod. What are you doing? I mean, how much more grounded can we get than that pool structure? To me, driving a ground rod right there is making sure the pool doesn't move or something. We're staking it to the earth or something. It serves no purpose as far as the equal potential bonding grid. You're bonding components together, not grounding. Once you've done all that bonding, drop the end of it and get away from it. There's no requirement in the code that says you need to run that back to the panel board either. Matter of fact, the code ought to say you shouldn't. You're prohibited from doing that. The code just simply says you don't have to do it, but I think it ought to say you're prohibited from doing it. If you did that, you're providing a superhighway for any fault imposed anywhere on that system to be run directly to that pool, which is, again, probably the most grounded thing on that whole property. Now, the code talks about here at 680.26 metal parts, and they're all specified at 680.26B, required to be bonded together. Remember what we talked about a while ago now when we're talking bonding here. What we talk about, grounding is what? Connected to earth. Bonding is what? Connected together. And that's what we're doing here, connecting pieces together. We can use a solid copper conductor. That conductor can be insulated, covered, or bare. It can't be any smaller than number 8. We can use rigid metal conduit, brass, other identified corrosion resistant metal as part of this bonding means as well. We can use the structural steel that might be in the deck steel there, something like that, as part of our equal potential bonding grid as well. And we'll take a closer look at that as we move along here. Our connections have to comply when we bond these parts. We have to comply with 250.8. 250.8 is a key requirement in Article 250 that talks about how to properly bond a or attach a bonding jumper or equipment grounding conductor or something to a, something like a metal component, a cabinet of a panel board or something like that. That's where it talks about a machine screw that engages at least 2 threads and listed fittings and things like that, ground clamps, things like that. This is what I see a lot of times when I visit a pool site, and this is where that installer installs in one continuous length, one continuous number 8 solid copper conductor, and goes to painstaking trouble to ensure that this thing is never spliced, never cut. You know, sliding ground clamps 200 feet down this line to make sure that there's no splices. I think this is one of those places in the code where it rears its ugly head and people get grounding and bonding mixed up. I think what's happening here when I see a guy using one continuous length right here and goes to, painstaking troubles to not splice this, I, I think, I'm just guessing here, but I think what's happening is he's taken a rule out of Article 250, 250-64C. Remember that rule that says that we have to install grounding electrode conductors in one continuous length without a splice. What is this conductor right here we're looking at? It's certainly not a grounding electrode conductor. It's a bonding jumper, period. That's what it is right here. But I think the reason you'll see this in one continuous length a lot of times is a guy will take that rule in 250, 250-64C that applies to a grounding electrode conductor and apply it to this bonding jumper back here in 680. And nowhere in the code does it say you have to do that. And the sad part of that story is a lot of times it's not the installer doing this, it's the inspector telling him to do this. The inspector is misinterpreting the code right here. This guy used 210 feet of number 8 solid copper wire and used all kinds of labor to get this accomplished. And his competitor used 75 feet of wire and a whole lot less labor and accomplished the exact same thing. And the code is perfectly acceptable with this right here. What's going on right here, guys, is the structural steel up here in the deck steel right here. That is your equal potential bonding grid. Now, attach your metal components to it and get away from it. 5 feet and hit the ladder. Another 5 feet and hit this metal fence that's within 5 feet of the pool. 45 feet over here to where the circulating pump is located. Nowhere in the code does it talk about having to do that right there. Does that meet code? Yes, but it's not required to be installed in one continuous length without a splice. You simply have to accomplish bonding of all of these metal components that are spelled out at 680.26b. And we'll take a look at some of those individually here in just a second. Now that fitting right there that I use, that clamp right there, is going to have to be identified for what? Going to have to be identified for concrete encasement, direct burial, and that's actually what that little label right there is telling us, is that this fitting is listed for concrete encasement or direct burial. So use a fitting listed for the application. That clamp right there is also going to have to be identified for what? Use with rebar. You can't just take a pipe clamp and, take the bottom part loose and turn it over. It makes a pretty snug fit right there, but that's not identified for that type of application. And they do make a clamp that is identified for rebar, and I think we've got some pictures of it coming up. Oh my gosh, look at that. Oh Lord, everybody, let's run, jump out the window. A splice. Oh my gosh. That's not installed in one continuous length without a splice. Great. As long as I use a fitting that is listed for that application right there, that's perfectly acceptable right there. There's that same shot right there. You need to use clamps that are identified for such applications, either direct buried or concrete encased or whatnot. And that's not a big concern, right? We don't have to worry about using clamps that are not listed for that type of application. That clamp right there was I actually came across that clamp right there. My sister-in-law had bought a house. The house was, when she bought it, was 20 years old or so. Um, but it had a brand new service. Somebody had upgraded the service, and the service was about 2 years old. And they used this clamp right here on a ground rod driven below the meter base there. And of course, that clamp was not identified for direct burial or concrete encasement. And after about 18 months, that's what it looked like. You think we had a good connection right here to that ground rod that it was connected to? I don't think so. Here's a clamp that is identified for direct burial concrete encasement. It's also a clamp identified for use with rebar. The clamp, you're going to find a lot of information on the clamp itself. This one's telling us that it's identified for direct burial. For the most part, when you make a connection like this, it's um, required to be uh, accessible. But there's an exception to that rule that says, for direct burial, it's not required to be accessible. This particular installer right here installed this can looking thing right here everywhere where he made a connection like this. Again, is there anything wrong with that? No, not required by code, but yeah, that an exception would say that's not required to be identified. Accessible if it's a clamp listed for direct burial and it's going to be a direct buried connection. So when we get to 68026, Part A is our performance. That's where it tells us what the equal potential bonding grid is for equal voltage potential between metal parts and all. And then 68026B gets into our bonded parts. And about the 2011 code, I believe it was, somewhere in there, Code Making Panel 17 did a great thing right here in that they broke apart the requirements for the deck steel versus the belly steel, the conductive pool shell versus the perimeter surface. And prior to the 11 code, all of that was lumped into one requirement. And you got different rules for your belly steel than you do your deck steel, and they needed to be broken apart. And that was a very positive thing that occurred back there 2 or 3 code cycles ago when panel 17 did break apart your belly steel requirements from your deck steel requirements. And then you have metal components, your underwater lighting. We saw those forming shells that have to be bonded to the equal potential bonding grid, metal fittings, electrical equipment like your circulating pumps and things like that. Then fixed metal parts, that would be your metal fences within 5 feet of the pool, a metal awning, a metal um, frame for a window or something would be considered fixed metal parts. And then item C, paren C down there, talks about actual bonding of pool water, which we will look at here in just a second. Separated into 2 different parts, which was a great thing to happen. It does talk about bonding of conductive pool shells that either have structural reinforcing steel or a copper conductor grid system. Poured concrete, pneumatically applied or sprayed concrete blocks, painted or plastered coating, that's all considered conductive materials. Now, vinyl liners, fiberglass component pipe shells are considered non-conductive pool shells. So if you had a non-conductive pool shell, then you couldn't rely on, your uh, copper grid system or structural reinforcing steel, things like that. You'd typically have to rely on something like a solid number 8 copper conductor or something for bonding of components around a non-conductive pool shell. So there's my conductive pool shell, my belly steel, and I have different rules for that perimeter surface, the deck steel. And again, panel 17 has done a nice job of breaking those two components apart at 680.26b. So let's look at where we have structural reinforcing steel. If it's unencapsulated structural reinforcing steel, it's required to be bonded. And again, for the most part, that non-encapsulated structural reinforcing steel can serve as our equal potential bonding grid. We just need to tie stuff to it. Your normal tie wires that the concrete man's going to install can serve as a bonding means between that structural reinforcing steel. And a lot of times people will kind of get caught up with, oh my gosh, that you got unqualified people and, is that, don't worry about crap like that. I mean, IEEE has done studies before years ago that, showed that um, once you get concrete around that structural steel, it's just as conductive with or without those tie wires as whether they're there or not. The tie wires there are simply there to hold that structural steel in place until I can get some concrete around it. That's period. That's it. Your structural steel can also include welded wire mesh. A long time ago, the code used to, I think it even had the term rebar in the code, and that was changed to structural reinforcing steel so that it could include other than just rebar, something like welded wire mesh. Where structural reinforcing steel is encapsulated or in a non-conductive compound, or you don't have structural reinforcing steel. The cool decks, things like that don't have structural reinforcing steel, then a copper conductor grid system is your method for bonding your conductive pool shells. Now we're talking about the belly steel right now. So there is some reinforcing steel that can serve as the equal potential bonding grid. It's not encapsulated. It's a conductive pool shell, and it needs to be part of our equal potential bonding grid. There's another one right there. That's, and in a lot of places in the country, I know they do that here in Texas, but I've seen it in several places around the country where they'll put the steel in for the belly steel right here, but they'll also leave 4 or 5 feet of rebar sticking up right here. They'll go ahead and pour this right here once it's inspected and all, but they'll leave these pieces right here sticking up out of the deck to where they can fold those over into the deck steel to bond the belly steel to the deck steel. There's some reinforcing steel that is encapsulated. I don't know if any of you have ever run across that. I have never seen this installed at a pool environment other than on the coast area in Florida. I did see some of this installed down there in that area where, very, very corrosive environment there by the ocean. And I have seen that installed in those locations, but other than that, I've never seen the encapsulated reinforcing steel. But if you do encounter this, this is considered non-conductive. That's a plastic coating around that rebar right there that makes it considered non-conductive. And so if you had this encapsulated non-conductive rebar, then you couldn't rely on it as part of your equal potential bonding grid. You'd have to install the copper grid system or something at that point. Here's a non-conductive pool shell, a fiberglass or plastic type component. Now they do have steel up in the deck right here that could serve as the equal potential bonding grid. But with something like this right here, now you're going to have to more than likely rely on a number 8 copper bonding jumper, and they even make a little trough to lay that in to catch all your metal components around that non-conductive pool shell right there. There's that same pool right there. Now, again, we're not talking deck steel right now. We're talking belly steel, conductive pool shells right here. If you don't have structural reinforcing steel, in other words, it's not available or it's encapsulated, then your alternative right here is a copper conductor grid system right here. And that's your only option at this point. And that copper conductor grid system has to incorporate number 8 American wire gauge bare solid copper conductors bonded together to each other at all points of crossing, complying with 250.8 again. It has to conform to the contour of the pool. Has to be arranged in a 12 by 12 network of uniformly spaced perpendicular grid patterns with a tolerance of 4 inches there. Has to be secured within or under the pool at not more than 6 inches from the outer contour of the pool shell. Now, again, guys, we're talking pool shell right now. We're not talking deck steel. There's different rules for the deck steel that we'll talk about in slides coming up. So if I encounter a pool with encapsulated rebar or something, or we don't have any rebar at all, then for the belly steel, my alternative option is that copper conductor grid system with these provisions right here. And you're looking at quite a bit of labor, I would suspect, involved with that copper conductor grid system right there for your belly steel. I've had people tell me that if they were to encounter something like this right here, even though it's not necessary for the structural integrity of that pool, they might go to your big box stores and buy some welded wire mesh and install in the belly steel right there, in the belly structure right there, simply to serve as structural steel to get around, I guess, if you will, this copper conductor grid. I think you could install that welded wire mesh, even though, again, it's not even required structurally. I think that might be a easier alternative, less expensive alternative than your copper conductor grid system, because again, the code says where I don't have structural reinforcing steel available, then I have to use that copper conductor grid system. Well, if you installed welded wire mesh there, then you would have structural reinforcing steel. So I didn't say that. If anybody from NFPA is listening, I didn't say that, okay? And if you do have to install the copper conductor grid system, then again, you're going to have to comply with those requirements right there, the 12 by 12 network of uniformly spaced grid pattern and so on. 12 by 12 network of your copper conductor grid system. And again, guys, that's your only alternative. If you don't have conductive structural reinforcing steel. As far as the belly steel, our conductive pool shell requirements are concerned. Now there is commercially available grid systems that you can go purchase if you didn't have structural reinforcing steel. You think the manufacturer of this is proud of that? In other words, is he going to give you this? I doubt it. So they're pretty proud of this, and it comes with a pretty good price tag. But they are available. And that would certainly meet all those requirements that we just got through looking at, that 12 by 12 network pattern, and you could install it 12 or 6 inches, apply it to the contour of the pool and so on. Now let's talk about our perimeter surfaces. We just got through talking about the deck, the belly steel. Now let's talk about the deck steel. It has to extend at least 3 foot horizontally from the inside wall of the pool. And that would include unpaved surfaces as well as poured concrete surfaces. So if you had a pool where one side you've got a deck and the other side right up to the pool is grass, the yard, then you would have to install some type of a equal potential bonding grid even on that grass area over there, which typically is achieved by a number 8 solid copper conductor, 4 to 6 inches below the surface of the ground there and all. Has to be attached to the belly steel, and that has to be achieved at least 4 points uniformly spaced around the pool. And that's why a lot of times you'll see that rebar stuck up out of the belly steel 4 or 5 feet, where they can just lay that over into the deck steel to comply with this requirement right here, that the belly steel and the deck steel be conductive and attached together at least 4 points. The perimeter surface is going to include all of those areas, 3 feet from the pool, unless again it's separated by a permanent wall or barrier. That wall or barrier would have to be at least 5 feet in height in this requirement. And on the other side of that 5 foot permanent barrier, the equal potential bonding grid would not be required. Now, if you don't have structural steel, then there are 2 alternative methods here in the 20 code. In the 17 code, you only had 1 method, but the 20 code gives you 2 options right here if you don't have structural reinforcing steel. So, your deck steel and your belly steel would have to be connected at 4 uniformly spaced, at least 4 points. If you had a permanent wall here, then your equal potential bonding grid would not be required over here, but it would be required right here. And it would be required for that structural component right there. Again, your structural reinforcing steel for your deck steel or perimeter surface could include welded wire mesh. It could certainly include rebar if that rebar is not encapsulated. If it's not available, then at that point your option is copper conductors, a system of copper conductors, which they call now in the 20 code a copper ring, And that was your only alternative in the 17 code. For the 20 code, that same copper grid system that we saw for the belly steel can also be employed for the perimeter surface deck steel as well. That was again added for the 20 code. So either the structural reinforcing steel, or if you don't have structural reinforcing steel, or the reinforcing steel is encapsulated, then a copper ring system or a copper grid system would have to be employed for the perimeter surfaces. We've already covered the belly steel. We're talking now about the deck steel or perimeter surface right here. What are you looking at right there, folks? You're looking at your equal potential bonding grid. Now, attach things to that need to be bonded, your ladders and circulating pumps and so on, and you're done. You can see that right there. Where that's part of the rebar, that's part of the belly steel that was stuck up out of the belly steel right here, and then where they could just bend that over, there's another piece, there's another one, and uniformly attach the deck steel to the belly steel right there. Some people would look at that and say, boy, what a nice deck that's going to be once that gets finished. What I see right there is an equal potential bonding grid. And now I just need to attach things to it. I don't know why people have so much issues with associating this right here as the equal potential bonding grid, but that's what it is. Now, if I don't have this, it's either a cool deck system or, with the fiberglass components or whatever, or this steel is encapsulated or something like that, then here's my alternatives right here. If that structural reinforcing steel is not available, I could employ at least one number 8 bare solid copper conductor. Can I have more than one? Yes. That follows the contour of the perimeter surface, in other words, the deck. If I have to splice it, or if I do splice it, then yes, I have to use a listed splicing device or exothermically welded process, because it's going to be encased in concrete more than likely. But there is provisions to allow a splice, which kind of goes against the grain of 250-64C back there that people want to bring into this bonding requirement for some reason. And there's even provisions at 250-64C that will permit you to splice a grounding electrode conductor under certain conditions, exothermically welded irreversible compression fitting, but that's a whole nother story. Now, if I employ this copper ring system, in other words, I don't have structural reinforcing steel on the deck here, and I've chosen to employ this copper ring system, least number 8 bare solid copper conductor, and it has to be installed 18 to 24 inches from the inside wall of the pool. It has to be secured within or under the perimeter surface. In other words, again, the deck, 4 to 6 inches below subgrade. I would consider that grade and that subgrade right there. So if I don't have any structural reinforcing steel and I choose to employ this copper ring system with this number 8 solid copper conductor or conductors, then 18 to 24 inches from the inside wall of the pool and 4 to 6 inches below subgrade is where I would install that component. There you see one number 8 solid copper conductor running around a non-conductive pool shell to catch any metal parts associated with that particular pool right there. Now, this is new for the 2020 code that has recognized that copper grid system that we saw that you were required to employ if you didn't have structural reinforcing steel for the belly steel. You can incorporate that same copper grid system or something close to it for your deck steel as well. Whereas again in the 17 code, your only alternative method was that number 8 solid copper conductor. The copper grid again has to consist of number 8 solid copper conductor arranged in that 12 by 12 network pattern, so on, just like we saw with the belly steel. Has to follow the contour of the deck, the perimeter surface, has to extend at least 3 feet horizontally from the inside wall of the pool and secured within 4 to 6 inches below subgrade again. So if I didn't have any reinforcing steel right here, I could employ my copper grid system, for the deck right here, as well as for the belly steel if I had to do that. But I can also employ that copper ring, for this area over here that's not going to be unpaved if I choose to do that. You got some choices here. Now, all metal components of the pool, and that would be your structural reinforcing steel, things like that, are permitted to be part of, or not permitted, required to be part of your equal potential bonding grid. And again, the tie wires are a suitable means of connecting structural steel together, or bonding if you choose to say that. If the reinforcing steel is capsulated, the reinforcing steel can't serve as the bonding method. It's not conductive. So metal components that are conductive have to be incorporated into our equal potential bonding grid. If it's a non-conductive structural component, rebar, then it can't be serve in the equal potential bonding grid because again, it's not conductive. There's the deck steel. This is part of the belly steel coming up, and you see it connected with the normal tie wires. We're using a clamp listed for the application there. Hopefully that's a rebar clamp. It actually looks like a pipe clamp that electrician has jury rigged there. Your normal tie wires can serve as an acceptable means of bonding pieces of rebar together. Your underwater lighting, that forming shell, needs to be part of or connected to the equal potential bonding grid, again, unless it is a low voltage contact system with non-metallic forming shells. So that right there is required to be attached or connected to the equal potential bonding grid. So again, everything's at the same voltage potential. Marry that piece of equipment right there to the metal ladder and the reinforcing steel and so on. You want it married, you want it connected together, so it's at the same voltage potential. Now, the code does address metal fittings that are isolated, small isolated parts, not over 4 inches. An example of that might be, sometimes you'll see in the side of a pool, you'll see a little ring, a little metal ring in the side of the pool where you can attach a rope that kind of separates the deep end from the shallow end. And if that little ring, that metal ring that's embedded into the side of the pool there, is less than 4 inches there, then you're not required to bond that to the equal potential bonding grid. Can you bond it? Absolutely. If there's any question, bond it, but not required to on a small isolated part like that. Metal fittings that are attached to the pool and are going to be in contact with the pool water and all, yes, those are required to be bonded. Now, with your pool ladders, you probably ought to be a little careful right here. A lot of times, on it's not the rough end, but pre-pour, you'll just see a couple of cups, metal cups right here that these ladders kind of fit down into, and that's what you're actually bonding is those metal cups right there that are embedded in the concrete. And sometimes I'll see a guy only hit one of those cups, and you might be a little careful there because a lot of times, the ladders, the steps, the rungs themselves are plastic, and there's really no metal connection between that railing and that railing. And so probably a good idea to hit both of those cups right there to ensure that that railing right there is at the same voltage potential as that railing right there, if that's not metal right there. Sometimes they are metal. There's a metal piece under that plastic fitting, but a lot of times it's just plastic. So I would highly recommend hitting both of those railings with your equipotential bonding grid. Fixed metal fittings, like these right here, are all required to be connected to the equipotential bonding grid. Same voltage potential is what we're trying to achieve right here. Metal anchors for pool covers. Those were added, I believe in the 20 code here, those were added to some of those small conductive parts that were not required to be bonded because, how likely are those to become energized and so on. Your electrical equipment, regardless of its location, most of that equipment that we just got through looking at was required to be bonded primarily because they were within 5 feet of the pool. When it comes to your equipment that circulates water and are associated with the pool itself, like a pool heater, pool pumps, and so on, those are required to be connected to the equipotential bonding grid regardless of their location. They may be 65 feet from the water's edge, but they still required to be connected to the equipotential bonding grid. Every drop of water in that pool is going to come through that equipment right there. A pool pump that is of the double insulated type is not required to be bonded. And we'll see some of that here. And some of this equipment, is required to be both grounded and bonded. I'm going to achieve grounding of this motor here by what? Connection to an equipment grounding conductor, but I also have to connect it to my equipotential bonding grid with that bonding jumper associated with the equipotential bonding grid to put all of this metal components, non-current carrying metal parts of these components at the same voltage potential. And again, the manufacturer provides us with some of these terminations to help us achieve this equipotential bonding. Pool pump motors, will have that external lug. I've seen these external lugs even on it'll be a completely plastic housing, or it'll be a double insulated pool pump motor, and it'll still have this lug back here. And I asked a manufacturer one time, a manufacturer of this type of equipment, why they put that lug on there, even on a plastic housing here. And he said, labor. It was just cheaper to put a lug on every one of them than it was to try to determine which ones needed it and which ones didn't. And I said, well, I hope you're kind of causing some confusion out there in the for the installer. When you put that lug on there, that's not required. And on a double insulated pool pump motor, that'd be a violation to connect it there. But a lot of times you'll still see those lugs like this, even on a double insulated pool pump motor. So be careful of those. Here's a junction box that has some bonding lugs provided by the manufacturer on the bottom of it there. There's a pool heater with a bonding lug from the manufacturer. And here's the back. Here's an insert of that motor right there. And again, manufacturer provided me a lug to connect this to the equal potential bonding grid and make sure all that equipment is at the same voltage potential. This is that requirement for the double insulated pool pump motor. But if you have a double insulated pool pump motor, you still have to have a bonding jumper in that vicinity in the event that in the future that double insulated pool pump motor might be replaced with a non-double insulated pool pump motor. You want to have a bonding jumper from the equal potential bonding grid over here in this vicinity right here. That's a double insulated pool pump motor, but 5 years from now, it may be replaced with a non-double insulated pool pump motor. And in that case, it would need to be connected to this equal potential bonding grid. So the code calls for this bonding jumper or bonding conductor to be in this vicinity. Again, in the event that that double insulated pool pump motor be replaced with a non-double insulated pool pump motor. It has to be connected to the equipment grounding conductor of the pool pump motor if there's no prior connection, which it probably won't be. All fixed metal parts like a metal railing or a metal fence or something, metal casing of a window, if that window is within 5 feet, it is required to be bonded. Sometimes that'll get missed, or the metal railing for that sliding glass door. If that happens to be within 5 feet of the inside wall of that pool, it would be required to be bonded so that everything is at the same voltage potential. So that I won't serve I touched this metal railing right here around this sliding glass door, and I touched this fence right here, or this railing right here, and they're at different voltage potentials. Again, I'm going to serve as the conducting path to equal out the voltage between those two. I want that right there to do that in place of me. I hope there's no voltage there at all, but even if there is voltage, if it's at the same voltage potential, and you're not grounded yourself, then you won't even know there's voltage there because it's already at the same voltage potential. What do you think about that window right there? That's getting close to within 5 feet of the water's edge there, isn't it? What about that metal fence right there? Is that less than 5 feet from the water's edge right there? I think it is. Matter of fact, I know it is because I measured it. And that would be required, hopefully, when all that was installed, that it was connected to the equal potential bonding grid around that spa and that pool, so that, again, if I contact that and this, it's already at the same voltage potential. Yes, easily within 5 feet of the water's edge there. So, and boy, I hope that fence is bonded to the equal potential bonding grid. Fixed metal parts might be a Haydite brick wall right here or something. And you see the installer ran a bonding jumper over here to ensure that that's going to be at the same voltage potential as that once everything gets finished. What do you think? You think the guy that installed that grill right there ensured that metal component, fixed metal component right there, is connected to the equal potential bonding grid of that pool? I hope so. I doubt that happened, but I hope it did. Pool water. We are required to bond the pool water. Now you can achieve that with, remember those ladders and railings that we saw going into the pool? If we have at least 9 square inches of that metal that's already bonded to the equal potential bonding grid in contact with the water, then that ladder or that railing can serve as the bonding means for the pool water. So those are already bonded, and if I have at least 9 square inches of metal in contact with this water, then I've quote unquote bonded the pool water. I don't have to go to other achievements to get that accomplished. It's already bonded. That metal housing right there, if I have 9 square inches of it, or this right here, and that's bonded to the equal potential bonding grid, and I have at least 9 square inches right here, then that can serve as bonding of the pool water as well. They do make a lots of fittings that can comply with 68026C in bonding of the pool water. If we didn't have pool ladders and things like that, then there are commercially available components that you can fit right into the plumbing for the pool. Every drop of water that goes in and out of that pool has to cross right over that right there. And according to the manufacturer, we've got 9 square inches right there that every drop of water comes across, and we have quote unquote bonded the pool water with that provision right there. Folks, we're out of time. We got to where we wanted to get to. We're just about out of our permanently installed pools. I thoroughly enjoyed being your facilitator today. Hope you got something out of the requirement here.
And there you have it, the best electrical safety education in the world, taught by the leading electrical safety experts in the world. Well, now that you've experienced one of our educational sessions, I hope you'll go online and join IAEI as a member. If you do so, we're going to give you your next educational offering for free.